welcome to this interesting session on SQL full course. So in this session, we'll mainly understand the different concepts related to SQL. So without wasting any further time, let's take a look at the topics for today's session. So we'll start today's session by understanding the data definition language commands, in which we'll understand what is relational database management system, how to normalize your database management systems, how to create, delete, and alter database objects, and also get an understanding about the different types of constraints present in database such as create, alter, and delete. Once you understand the data definition language commands, the next topic would be the data manipulation commands. So in the data manipulation language commands, we'll basically understand how to enter and update the data in existing tables using SQL commands. Apart from that, you'll also understand how to delete data from single tables and also how to fetch and show the data from databases using various kinds of commands. And finally, we'll end this topic with the SQL operators such as comparison, logical, and so on to get an understanding of how you can play around with your databases. After you get an understanding about the data manipulation commands, we'll next get into how to retrieve data from multiple tables. So in this part of the session, you'll basically understand the different types of joins present in SQL, that is the inner, left, right, and cross. And after you understand the joins, the next topic would be the inbuilt functions in SQLs. So in this topic, we'll basically look into how to use the built-in functions in SQLs and also understand what is group by clause and having clause. And finally, we'll end this session by understanding how to create advanced database objects, in which we'll mainly focus on the stored procedures, functions, and triggers. So I hope the agenda was clear to you guys. So today we have a special guest, Anil, who's going to take this session forward. So over to you, Anil.
Hello guys, this is Anil from Adureka and welcome to SQL Essential course. So let's start with what is RDBMS. So as you can see on the screen, RDBMS basically stands for Relation Database Management System. So basically in RDBMS, we define the data or we store the data into collection of tables. So it is a two-dimensional database. So as I mentioned, it stored the data in tables and the tables have rows and columns. So some of the properties of relation database, as you can see on the screens, its values are atomic, columns values are of the same thing, columns are undistinguished. Sequence of row, how the data is stored is of insignificance. We can store the data in any sequence, and all the columns have a unique name. Most of the database which we know as of the like Oracle, MySQL, all are relation database management system. And SQL is the common query language for all database management system. As we discussed that RDBMS is basically we store the data into collection of tables. So when we store the data in collection of tables, it is very important that data is organized properly. So we apply the concept of normalizations for the better management of DBMS. So as you can see, normalizations is the process of organizing data to avoid duplications and redundancy. So we apply normalizations to database systems to minimize duplicate data, data modification issues, to simplify our queries, because we don't want to run into complex queries when we fetch the information from database. If our database is not properly normalized, then we may face issues when we try to update any records in the database. There are various rules for normalizations, but generally we follow third normal form in order to organize our data efficiently. So we have first NF, that is first normal form, second normal form, third normal form, and the end we have Boyes and Codd normal forms. But it is enough and it's sufficient if we satisfied up to third normal form. Okay, so what is first normal form? So as per the first normal form, as you can see on the screen, that each set of column must have a unique value. It means every column should have a single value in it. On the screen, as you can see on the left hand side, we have a student table, and this table has 3 columns: student, age, and course. But in the first row, as you are seeing on screen, that we have 2 values for a single column, CR001 and CR005. Because of the multiple values in a single column, it is violating first normal form. So in order to satisfy first normal form, we have to split the row into multiple rows. So after splitting, on the right hand side, you can see that we have split the row first into 2 rows, Adam 15, and the course is CR001, and another row is Adam 15 CR005. So we have split the multiple values into single values, and now our table is satisfying the first normal form. Let's move to the second normal form. As per the second normal form, there must not be any partial dependency of any column on primary key. So first of all, what is primary key? So a primary key is a key which helps us in identifying a unique row in a table. Most of the time, the primary key is a single column, but sometimes more than one column can be combined to create a single primary key. Now, as you can see on the screen, our table was not satisfying the first normal form, so we have split into two rows. So in this table, we cannot consider student as a primary key because, as I mentioned, that the very first prerequisite of a primary key is that no two row can have the same value for that key. Here, in the first column student, we have Adam as two entries of Adam. So student is not a primary key. So in order to make a primary key, sometimes we concatenate or add one more column to our primary key. So in our case, we have student and course as a primary key. So a primary key generally contains a single column, but sometimes as per a business requirement, we may add multiple columns in the primary key. So in this table, student and course together have a primary key. Now, second normal form states that in order for a table to be satisfy the second normal form, it first satisfy the first normal form. And after that, all the columns should depends only on the primary key and they should not partially dependent on the primary key. So as of now, and you can see in this table that column age only depend on the student and not on the course. So age is partially dependent on the primary key because our primary key has student and course in it. So that is the reason it is not satisfying second normal form. So in order to make it satisfy the second normal form, we have split the table into two tables now. The first table we have student as a one column and age as another column. So age is now dependent on student, as well as in the second table we have student and course. So the course is also dependent on the student. So now the columns are not partially dependent on primary. So in order to satisfy the second normal form, a table should first satisfy the first normal form. As we can see that no columns has a multiple values in it, so it is satisfying first normal form. And the second normal form states that any non-key columns should not partially dependent on primary key. So in this, age is dependent on student as well as course is dependent on student. So our table is satisfying the second normal form. Let's move to the third normal form. Third normal forms applies that every non-prime attribute of a table must be dependent on primary key. Or we can say that there should not be a case that a non-prime attribute is determined by another non-prime attribute. So let's take an example here. So this example will help us understand what the statement means. So we have a student table here, and these are the columns: student ID, student name, date of birth, street, city, state, and zip. So we have 7 columns in our student table. And in this table, the student ID is the primary key. So the third normal forms states that all columns should be dependent on the primary key only. So if you'll see street, city, and state, street, city, and state, these 3 columns are basically dependent on the zip code of that area and not on the student. So that is the reason it is not satisfying the third normal form. So in order to make it satisfy the third normal form, we have again split the table into 2 tables. So one table we have student ID, student name, date of birth, and zip, and the address table we have zip, street, city, and state. So this is how, guys, we design our database. So it is very important when you design your database, when you decide that, okay, these are the tables which we are going to create. So you need to first apply all the normal forms. So your database will be more efficient. It will allow you to remove any redundant data or duplicate data from our database. So I hope the first, second, and third normal forms are clear. And the important part here, guys, is that the third normal form, for example, any normal form should satisfy the previous normal form. It cannot be the case that my table is satisfying the third normal form, but it will fail the first normal form. So second normal form, it has to be satisfy the first normal form, and the third normal form, it has to satisfy the second normal form. After we know the best practices to design our database, we'll discuss about the data types in SQL. When we store the data in our database, we know that what kind of information we are storing. It can be integer value, it can be strings or characters. We can store the salary, it can be monetary data, for example, money or the currencies. We can store the data in terms of date and time, that when some action has happened, or when an order is made, or when we purchase certain items. We can store the binary string, for example, we can store images, or we can store pictures in our databases, so we store in the binary form, and so on. So basically we will define there are four broad categories of data types in SQL. One is the character string, numeric values, date and time, and binary. So let's discuss about the character string data type. So we have these 6 type of string data types. One is char n, and then we have nchar n, varchar, varchar max, and varchar, and varchar max. So these slides are self-explanatory, and it mentioned that it basically depends upon what is the size of data we can store for these data types. Apart from this, guys, we have this varchar and char. So var basically stands for variable length character, and this n stands for Unicode characters. So if we want to store the data, for example, non-English data, I want to store some Japanese language or some Arabic keywords, then we basically use nchar or nvarchar. It basically stores for Unicode characters. Character is a static. For example, if I define character 20 and I'm trying to store values of 5 character, then in order to match the defined data type, the right side of my data type will be padded with the blank spaces. So we decide basically whether we want a variable character or the static character. We have numeric data type. So in numeric data type, we have int, tiny int, small int, big int. So guys, this tiny, small, big int, it all depends upon the size of the data we want to store in our database. So as per our business requirement, how small or the big data we want to store in database, we decide our data type. If you want to store the data in terms of currencies, so we have money, again money, based upon what is the size of data we want to store in money data type. We have money and small money. We have decimal. In the decimal, as you can see, we have 2 parameters, P and S. So it's basically stands for precision and scale. So the maximum precision is 38 digits. Again, we have numeric, float, and real. So these data types you'll see are basically more of a in line with the database of the basic language like C, C++. We have all these data types. Date and time is one of the most important data type, guys. So we have different format of data types available for this section. We have date. So as you can see, the date data type stores dates between Jan 1, 001 and December 31st, 999. And its length is basically of 3 bytes. And if you want to store time along with date, then we have date time. So in the date time also we have 2 different date. One is date and one date time too. It also depends upon whether we want to store the time in milliseconds, or we want to include the nanosecond part also. We have then again small date time, and if you want to store only the time component, not the date part, then we can use the data type time. In the end, we have binary data type. So we have, as we discussed, we have bit, store a single bit of data. For example, if you want to have true and false, 0 and 1. We have binary, stores n bytes of binary data. We have var binary max. So we generally use var binary max when we try to save data. For example, let's say some images and pictures where we don't know about the size. It can change dynamically at runtime. It's a big data, so we generally use var binary. So I hope you are clear with the basic data types. So far we have discussed what RDBMS is, how we design a better database management systems by applying the rules of normalization. So we discussed 3 normalization forms: first NF, second NF, and 3NF. And then we discussed that what are the various data types which we can use to store our data in database system. After that, we'll discuss about the various SQL statements. So generally in SQL, we write queries. So our queries falls into 4 broad categories. One is data definition language. One is data manipulation language. We have data control language, and we have transaction control language. So data definition language that we are going to discuss in the coming slides, and we'll discuss about the schema of our database, that how we create the database object, how we modify our database objects, and if not required, how we can drop or delete those database objects. In data manipulation language, we do not manipulate the database schema. We basically manipulate the data which is stored in our database objects. So these are the four basic commands. As you can see, we have select commands, we have insert, update, and delete commands. So we modify the data, we retrieve the data, we update the data, and if not required, we delete the data. So the basic difference between deleting the database object and data is that when we delete the data, database object is there. It just we are deleting the data inside the object. And then we have data control language. So include commands such as grant, and mostly concerned with rights and permission. For example, a new member has joined in your team and you want to give the permission so that he can play around with your database, then you have to grant some permission to the new user. If someone is leaving your team or leaving your projects, in that case, you no longer want him to access the database. So in that case, we revoke the permissions with the person having on the database. So we use grant and revoke commands, and this falls under the data control language. Transaction control language is basically when we commit or the rollback the data. When we are saving the data, and we might be concurrently saving the data in multiple tables, and while saving the data, if there is an error in any one of the table, we basically roll back the entire data. So we use rollback or commit commands to save or roll back all the changes which we made to the database. So this falls under transaction control language. So as discussed in this module, we'll be discussing more about the data definition language, where we discuss about the schema of our database. So in order to start with, we have to first create our database. And in the database, again, then we'll create multiple different database objects like functions, store procedures, tables. So to start with, the very first step is that we need to create a database object. So in order to understand database, a database is nothing but it is an organized collection of a data. When I say organized, the data is stored in multiple tables. The tables are related to each other based upon the various business conditions or business requirements. And the main purpose of database is basically to operate large amount of informations by storing, by retrieving, and manipulating and managing the data. So I'll show you how to create a new database. So as I mentioned earlier, that after installation of Microsoft SQL Server, we have, in order to access the server, we need to open Microsoft SQL Server Management Studio. So if you will search for SSMS, that is SQL Server Management Studio. So this is how this icon will look like, and you have to open it. Once you open it, the screen will look like this. So on the left hand side, you have Object Explorer, and these are the various toolbox. So you can go through these toolboxes. It's a self-explanatory. So in order to create new database, we have to click on New Query, and it is a straightforward command to create a database. Let me increase the font size for better visibility. So we have to just write create database and the name of the database. So by default, as you can see, these are the databases here. These are the custom one which we have created, Edureka, AmpDB. These were the system database. And once we install Microsoft SQL Server, this database will be present by default. So the command is create the database and the name of the database. So all you have to do is, and the name of the database. So for example, I'm creating test1. So to execute this command, either you can select this query and then can press F5, or after selection, you can click on execute button here. So if there's no error while executing the command, you will get this message that command completed successfully. And in order to check whether the database has been created successfully or not, we can go ahead and refresh our database. So in order to refresh it, you have to right click the databases and just click refresh here. As you can see, the test1 database has been created. You can expand this and you can see by default in any database, you will see these categories will be present. But under tables, these are the system tables because we have not created anything custom as of now. So whatever is present under test1 database as of now is out of box. So creation of database is first step to manage the entire database objects or to start playing with the data. After creation of a database, we need to create some tables in it because table is where we store our data. And all other database objects are basically based on SQL tables. So as you can see on the screen, the basic syntax to create the table is create table. Then we have table name. What is the name we want to give it to our table? Then we define what are the columns we required in our tables and followed by the data type. We've already discussed what are the various data types present in SQL. So based upon our business requirement, based on our requirement, we define what kind of data type a column should have. So let me execute this command here. So let's create a table and see how we can create the table. So in order to save time, let me create one table for you guys. So we can delete this line or we can create a new query window. Let me again increase the font size. So guys, as you can see, we have to follow this syntax is very important, and the best part is that it is not case sensitive. It is not that I have to give everything in cap. I can provide in small, big font size, or it is not case sensitive. So you provide create table and name of your table. It can be any name. So as of now, let's giving the test table. And these are the columns which I am defining in my table. Employee ID, int, primary key. We'll discuss about what are the keys, and in the very end of this module, we'll discuss what are the various constant, how we can create a primary key, what is the use of it, what is foreign key. So we create one columns. As of now, I'm not making it primary key. I'm just defining the data type. So for employee ID, I'm defining the data type as int. Then I'm defining the last name. So let's make it more readable. I'm defining it as a last name, one column, and first name as another column. And I'm defining the data type as varchar. And I'm defining it's not null, that it is required to have a value in this. So if we want that certain columns are mandatory while we are inserting the data, then we have to make them not null. By default, it is null. So we have to explicitly write this keyword not null if we want to make those columns mandatory. Semicolon in the end is not required. It is not mandatory in Microsoft SQL Server, but if we will write this query in MySQL, then semicolon in the end of statement is required. So I'll execute this command, and if everything runs successfully, there is no error while executing this command, then we'll get this message command completed successfully. So in order to see, okay, now guys, important part, if I'll see that whether the table has been created in the database which we have created. So let me refresh our database and see the table is not here. So it is very important, guys, that when we create the table, we have to ensure under which database we are creating this table. So this window on the top will specify that which database we are using to execute these commands. So in order to create the database in test1 database, which we have created, we have to select this. If we don't want to select this, then we have to write the keyword use test1. So this ensures that we are creating this table under this database test1. Now, if I'll execute this command, execute successfully, and if I'll refresh my database now, I can see that the test table has been created in it. So this is how we create the tables. So you can expand this table and can see various columns in it. So we have created 3 columns. So since I have not mentioned, as I mentioned, that if I will not provide whether this column needs information, yes or not, then by default, it will be marked as a null. Means it is optional to provide values for this column. So we have to explicitly write not null if you want to make the column mandatory. A table can have many columns. So based on business requirement, we add the columns in it, and then we define the data type of the columns. I hope creation of a table is clear to all of you. Let's move to the next point. So you can try this example, guys. You can create a new table employee. So this has employee ID as one of column, and its data type is numeric 4, first name, last name, manager ID, hire date. Since it is a date, we have defined the data type as date here. Then we have job ID and department number. Okay, so we have created a table. Now there might be scenario that we might need to modify our table. We need to define or we need to redefine the schema of table. While creating the table, we may have missed any column. We may have wrongly defined the data type of any column, or we might not want certain columns and we want to drop those columns or delete those columns from our table. So to define or to redefine or to alter the schema of our database object, we use alter commands. So we use alter table commands to add, delete, and modify columns, or we use alter table commands to add or drop constraint on an existing table. So as of now, we'll discuss about the first point, and the second point about the constraint we'll discuss when we'll discuss about the various constraint in the coming slides. So as you can see, we can use alter table commands to add a new column in our existing table. We can use alter table command to drop a column, to remove or delete a column from our table. And we can again use alter table command to modify the data type of a column. So let's see how we can use it. Alter table, then we have to follow the name of the table. Let's assume that we missed age of the employee. So we are going to add a new column, age, in our database, age, and so this is the syntax. Alter table, the name of the table, add, name of the column, and then the data type. So we'll define add age, and we'll define data type as age here. So we'll select this and we'll execute. So it has executed successfully. So let's see whether this column has been added in our existing table. So we'll just right click our table and click on refresh here. As we can see, we have added a new column age in it. Since we have not defined it as not null, so it is again an optional. So it is up to us whether we provide the values for age while inserting the data in this column or not. Again guys, we can use alter table to drop a column from our table. Syntax is again same. We have to write alter keyword first, followed by the table keyword and the name of the table from which we want to delete our column. Then we have to use the keywords drop, again followed by keyword column and the name of the column. So guys, this is the syntax. So we have to replace the table name. So in our case, we have the table name as this table here, drop column and the name of column. So in order to remove the same column which we have added just now, so I'm deleting the column again. So we have to follow alter table, name of the table, the column which needs to be dropped. And now the important part is that if you have multiple queries in the same window, then please don't click on execute. Because if you click on execute on the top, it will execute all the queries present in the same window. So either you will write your query in the new window, or in order to execute the required query, you have to select that and then you can either click F5 or you have to click execute. It's mentioned that command completed successfully. So now if I'll refresh my table again, the column is no more. We have successfully deleted the column from our table. So this is one use of our alter commands, that we can add columns in it and again we can delete the columns from a table. Other than that, we can use alter table commands to modify the data type of any existing columns. So this is the commands for that. I'll go to Management Studio, paste it, and we have to replace the value in the angle bracket. So we'll have to define the table name. So we have test table here, alter column, name of the column. So let's assume we need to change the data type of employee ID from int to character. So I'll define it as, mention the name of the column of which we want to change the data type. And now we'll define what new data type we want. So I'm defining it as character 10. So if I'll go ahead and refresh this, I can see the data type of employee ID has been changed from int to character 10. And modifying the data type, we can use this alter table command to modify the constant, to add a constant in a table. Even we can use it to disable the constant. Sometimes we don't want to delete the constant, we just want to disable, and then as and when required, we can re-enable again. So we'll discuss this when we'll discuss about the various constants in coming slides. So these are the various examples, so you can practice these examples. So here we are adding a new column salary in the employee table, and the data type is numeric 10(2). In the second statement, we are again removing a column called job ID from employee table. And in the third statement, we are changing the data type of first name column, and we are making it to varchar 25. Good part here is that we don't need to provide the old data type. All we have to do is that we have to type the new data type. Now we have drop table statements. So in the drop table statement is basically, if you want to drop a table, we need to delete the entire table from the database. As of now, in the previous example, we have deleted a column from a table, but now if we want to delete the entire table from our database, in that case we use the drop table keywords. So syntax is straightforward. We have to write the drop keyword followed by the table keyword and the name of the table which we want to drop from our database. So let's assume we want to drop the table which we have created just now. In that case, we'll simply write the syntax here, drop table and the name of table. Guys, it is very important when you are dropping or deleting a table, because when you drop a table, the entire data in it will also get deleted. So we have to be very cautious while deleting the database objects. Select this and click on execute. Command is completed successfully, and if I'll try to go and refresh the tables again, I won't see the test table there because we have just now deleted it by executing drop table command. So far we have discussed that we can use create keywords to create a new database. When we create a new database, it is of no use because we have not defined our objects in it. The database will by default have all the out-of-box objects in it. So we have to first create our table so that we can store our data in it and can create various other objects. So we have created tables, we have created database, and after creation of a table, we saw that in order to modify any schema of any existing tables, then we have to use alter commands. We have to use alter keywords. So we have modified the data type, we have added a new column, we have deleted a column, we have deleted an entire table from our database. Now we'll discuss about the constants. So constant, basically these are the various rules which we apply on the table whenever a row are inserted, updated and deleted from our tables. So it even prevents the deletion of a table if there are dependency from other tables. So for example, as we discussed that this database is relationship database, so various tables have relations among them. So we cannot delete a table if it has a dependency on another table. We'll see that what kind of dependency tables may have in these slides. So define the constant at column or table level. So we can define whether the constant is only for the one particular column or the constant is for the entire table. So good part here is that it is not that we have to always apply the constant while creation of the tables. So let's assume that you have created a table and then you realize that you forget to add a constant. Then no problem. Even after creation of a table, we can go ahead and using alter commands, we can add constant in the existing tables also. So we will see now how we can add those, how we can add a constant while creating a table, or how we can constant after creation of a table. So before that, let's discuss what are the various common constants which will apply on tables or columns. So not null, as we already discussed, that specify that a column must have some value. If we won't provide not null, then by default the column will be optional, and it is up to us whether we want to provide value for that column while inserting data in a table. We have unique keyword, specify that column must have a unique value. So if I define a column as a unique, it means no two row can have the same value for that column. We have primary key. Primary key specify column or a set of column that uniquely identify a row. It does not allow null values. So guys, this is the difference. As you can see, when we say unique constant and primary key constant, both the constant states that it helps us to uniquely identify the values. Then what is the difference between unique key and primary key? So one basic difference is that unique constant even allows us to insert the null value. The point is that there should be only one single null values, because the moment you'll add one more null values in another row, then it violates the unique key constant, because no two row can have the same value for that column. But yes, for a single row you can have a null value, but which is not the case for the primary key. Primary key, if you want to make any column as a primary key, the first criteria is that the column cannot have null values in it. The second main difference is that we can have only one primary key in a table, whereas a table can have multiple unique keys or multiple unique columns in it. Okay, so let's discuss more about primary keys and how we create it. So as we discussed in the normalization also, that generally a single columns is a part of a primary key, but it is not that only single columns will be there. Based on business requirement, we can add more columns in a primary key. So a primary key can have more than one value in it. It can be 2, it can be 3. So those primary key which have more than one column in it, they are called as a candidate key. Let's see how we can create the primary keys. Okay, so far we have discussed about like how we can drop the tables from the database, and let's discuss about the various constant. So constant enforce rules on the table wherever rows are inserted, updated, and deleted from the table. So we can apply the constant at the table level or at the particular column level. Constant also prevents the deletion of a table if there are dependency from another table. So we as we discussed in the RDBMS, that RDBMS is a collection of related tables. It's a relational database. So if there are dependency between tables in terms of primary key and foreign key, if you try to delete a table, then it will give an error that the two tables are related and there's a dependency in other tables. So constant prevents the deletion of a table. The good part about constant is that they can be applied during creation of a table, and even we miss the constant while creation the table, then we can add the constant even after creation of the tables, like using alter commands. So before we see how we can apply the constants, let's discuss what are the various constant available. Common one, not constant. We already discussed about this constant when we created our table. So not null specify that a column must have some values. So if you won't provide this constant, by default SQL consider it as a null, and that column will become optional. So in order to make column mandatory, we have to explicitly provide not null constant while providing the data type. So we have to specify the not null after the data type. So let me show you. So in the last name, we have defined the data type varchar 50, and after that we define not null. It means that the value in this column will be mandatory and we cannot provide a null value while inserting data in test table. Whereas for employee ID, since we have not provided this constant, employee ID will be null and we may or may not provide the data while inserting in the test table. Then we have unique constant. Unique constants specify that column must have unique values. So if I'll specify the column as a unique, no two rows can have the same values for that column. Then we have primary key. Primary key specify a column or a set of column that uniquely identifies a row, and it does not allow null values. So as you will see, unique and primary, both of these constants define that column should be having a unique value. Then what is the basic difference between unique and primary key? Is that unique allows null value in it, whereas primary key does not allow null value. The second difference is that there can be only one primary key in a table, but there can be many unique key in a table. So this is the second main difference between these. Again guys, primary key, generally we have single column as a primary key, but based on business requirement, we can add more columns to the primary key. It may be 2 columns, it may be 3 columns. So a primary key having more than one in it is called as candidate key. So before we'll discuss about the foreign key and other constant, we'll first see what is primary key, how we'll define it, how we'll create the primary key while creating the table, and how we can add the primary key after we have done with the creation of the table. So let me move to Management Studio. And to save time, I have a few examples handy with me. So we'll create an employee table. So I'll open a new query here. So guys, if I want to make a key primary key, all I have to do is that I have to write the keyword primary key after my column. So if I'll execute this command, let me increase the font. Once I'll execute this, and if I'll refresh the table, I can see the employee table has been created. And if I'll go and see the key created on my column, employee ID. And you can see there is a prefix of PK, primary key. So you can check which column and you can see the key sign. So this is for primary key. So just by expanding the columns, you will come to know, okay, which column is basically my primary key. So you can check the keyword and you can check this icon before the column. So to create a column as a primary key, all you have to do is that write the keyword primary space key right after the data type of your column. So this is one way of creating the key. Some alternate ways also. So this is another way or the alternate way to create the primary key. So I'll just change the name of the table since we already created M table, and if I'll try to recreate the same table, it will give me an error. The table already exists in the database. So one database cannot have two tables with the same name. So let me show you. If I'll try to create the same table again, it will give me an error that there is already an object named EMP in the database. So it means a database cannot have any two objects with the same name. So you have to be careful. So let's create an employee one table here. So in the previous example, we have just added a keyword primary key after employee ID, but here I'm not adding that, but at the very end I'm defining the constant, and I have to write the name of the constant. Here I have not provided the name of my primary key constant, so SQL itself will provide a name of the constant. As you can see, we have not provided this PK underscore EMP underscore and followed by a unique ID. But in our case, if we are creating a primary key using this alternate approach, then we have to provide the keyword constant, name of our constant, and we'll define the primary key. And we have to explicitly in this parenthesis will define, okay, for which column we are considering for primary key. So let's create a primary key here. It's successfully created. So I'll go ahead and refresh the table. So here I'll see the columns. Again, employee ID is a primary key. If I'll expand the keys here, see the name is exactly same which we have provided, EMP underscore PK. Okay, so both this approach is good. You can pick any one of the approach to create the primary key. But there's a slight there's advantage of using the alternate approach. If I want to include multiple columns in the primary key, as we discussed that a primary key may have more than one column in it, then we cannot go with this approach. This approach is fine if we want to create only one column primary key. So if you want to consider multiple columns, then we need to consider the second approach, this alternate approach for primary key. Let me show you one example. Let's consider this example, guys. In this case, we are considering two columns for primary key, last name and first name. So I cannot go with the first approach. I have to follow the second approach where I have to explicitly provide the constant name here. So I'll go ahead and create the primary, the table again, and let me refresh. As you can see, we have successfully created employee 2 table. And since we have considered both of these columns for primary key, I can see the key icon in front of both these columns, L name and F name. Let me expand it. As we mentioned that primary key cannot allow null values. So by default, these columns are having not null. And if you'll see the keys name, this is the same name which we have provided while creating the constraint. So this is how we create the primary key while creating the table. But it is not that we cannot add primary key once the table has been created. So let's see one example where we will create primary key once the table has been created. Okay, so this is the syntax for that. Before that, let me go ahead and create a table. So what I'm going to do, I'm creating an employee 4 table, and I'm not providing this keyword here. I'm just providing not null. So I have created a table. So I have created successfully a table employee 4. Let me go ahead and refresh the tables again. So we have employee 4 tables, but there's no primary key here. And now I want to make employee ID as the primary key. So for that, we need to follow this syntax. We have to alter the table. Again, alter table not only helps us to add a column, to delete a column from the table, or to modify the data type of a column, but we can also use alter keywords to add a constant or to delete a constant from the table. So I'm using alter table. Name of our table, in our case, we have employee 4 as our table. So I've given the name employee 4. I'll provide name of our employee key, for example, employee primary key, and then followed by the keyword, and then I'll define which column I need to consider for my primary key. So we are considering employee underscore ID. So I've given employee underscore ID here. And if I'll run this particular SQL query, command completed successfully. And now if I'll refresh employee 4, I can see the key has been created. And if I'll go and see the columns, it's taking time. Yeah, I can see the employee ID is now the primary key. So we have seen both the examples where we can create the primary key while creating the table, or we can alter the existing table and add the primary key even after the table has been created. I hope this is clear, guys. Important part and most important part here is that please do not forget that we can have more than one columns in a primary key. And those primary key sometimes are called as candidate key. So let's continue our discuss, and we'll discuss about the foreign key. So guys, two tables can be related. And the two tables in the database can be related by means of primary key and foreign key. So first, let's define what foreign key is. So foreign key helps us to create or to enforce the referential integrity within our database. A foreign key means that value in one table must also appears in the another table. So when we join these two tables, the reference table is called as the parent table, while the table in which we create the foreign key is called the child table. So the foreign key in the child table will generally reference a primary key in the parent table. This is how we create primary key, or this is how we create relationship between tables by means of primary key and foreign key. So let's first see how we can create the foreign key, and then we'll discuss about the relationship. So if I create a foreign key, see now again let's revisit the point number 2. The point number 2 says that constant prevents the deletion of a table if there are dependency from another table. So if two tables are related by means of primary key and foreign key, and if you try to delete the parent table, then it won't allow us to delete the parent table because the parent table is referenced by the child table. So that is what the meaning of the sentence 2, that if there are relationship between tables, it prevents the deletion of a table. So let's see the syntax of creating foreign key. Again guys, like how we added primary key, we can create the primary key while creating the table, or we can modify the table and then using alter table commands or using alter keywords, we can add the primary key. Same way, we can create the foreign key while creating the table, or once the table has been created, we can go ahead, use the alter commands and then add a foreign key. So for this, I'll consider two tables, guys. As you can see on my screen, I'm considering, let me increase the font. Yep. So I'm considering two tables here. First is the product table. In product table, prod underscore ID is my primary key. And I'm creating one more a table called orders. And order underscore ID is my primary key. But I'm creating a foreign key, so the product ID of my orders tables will be related or will be connected with the product table by means of a foreign key. So let's see how we'll add. So let me copy these two tables and we'll open a new window in Management Studio. I'll increase the font and paste it here. So first of all, I'm creating my parent table, that is a product. So I'll select it and I'll execute it. So command completed successfully. If I'll go ahead just to verification, I'll just refresh this and I'll see, okay, it has been created successfully and all the columns are there. Product ID is a primary key. Now what I'm doing is that I'm creating a child table called orders, and the order tables will be referencing the product ID column, which is the primary key of products table. So this is the primary key of orders table, and this product ID, this second column, will be a foreign key, and this will be connected with the product ID of my product table. So in order to do that, we have to write constant explicit keyword. Then we have to provide the name of our constant. It can be any name. You have to decide. All we have to do is that we have to ensure that this constant does not exist in our database. Okay, it has to be unique value. Then we have to provide the foreign key. Okay, which column we want to consider for foreign key. So out of these three columns, our order underscore ID, prod underscore ID, and quantity, we are considering prod underscore ID for our foreign key. So I provided the prod underscore ID in the parenthesis. And then we have to tell, okay, which table we are referencing. There can be hundreds of tables in our database. So if I want to create a foreign key, I need to define the parent table for that, the table which we are referencing. So in our case, we are referencing the product table. So I've selected product here. And then in the parent table, which column we want to reference. So we have to first finalize the table, and in the table, then we have to finalize the key, which we will be referencing. So don't get confused, because I have the same name of the column in the child as well as in the parent table. And I'll execute this command. Successfully created. So if I'll go ahead and refresh the tables again, I can see product with ID. And if I'll expand orders, so guys, can you see the icon with this orange color is basically primary key, and this gray color is my foreign key. And you can see this keyword as a prefix FK, foreign key. So this is how we create a foreign key. So this is how we create while creating the table. And let me show you the syntax that how we can create the foreign key once the table has been created. Yep. So I will be creating it. So let's assume I have one table orders one, and have tables one's product one. So I'll first create these two tables. The tables has been created successfully. Now I want to add a foreign key once the table has been created. So I have to define alter table commands. Then I define which table I want to modify. So I want to modify the child table, that is the orders one. I'll define the constant here. I'll define the foreign key again, which column I need to consider. So we are considering again the product underscore ID. So I provide that in the parenthesis. We are referencing the product one since I've renamed the table. So I'm just renaming the table as a product one. And the column name is same here. So we have product underscore ID. So if I'll execute this command, this will go ahead and create a foreign key. So I'll refresh the tables of the database. I can see there's a table called orders one, and see these are the two columns, order ID and product ID. And the key is FK underscore product underscore ID one, which we have given. So this is how we create the foreign key, and we will discuss more about foreign key in the module 2 when we'll insert the data. One important part here, guys, is that when we create a foreign key on a child table, and for example, the data of a parent table is referenced in a child table, and if you want to delete the data from the parent table, it will give us an error that the data is already referenced in the child table. Sometimes there are business scenario where you want to go ahead and delete the data from the parent table, which is referenced in your child table. But you cannot do that because it will give you an error. But if we will define our foreign key in such a way that there is a cascade delete, that if I'll delete the data from the parent table, it will also delete the data from the child table, then while creating the key, we need to define this keyword on delete cascade. This is an important point, guys. So by default, your foreign key is having a relation of restrict delete. It means if you try to delete the data from the parent table, which is referenced in child table, it will give an error. The data is referenced, you cannot go ahead and delete it. In order to fix these issues, there might be business scenario when you want to delete the data from parent as well as child. Then while creating the foreign key, we have to provide this keyword on delete cascade. So this is all about foreign key, guys. So we have learned various constant. We discuss about the not null. That not null is used if you want to make our column mandatory, that it is mandatory for us to provide the data while inserting records. We discuss about the unique key. For the unique key, all you have to do is that you just have to write the unique keyword in front of your column. So unique keyword just define the unique key. We discuss about the primary key and discuss about the difference between unique key and primary key. Unique key may allow null keywords, but it only allow for one single row, because the moment we'll try to add null key in 2 rows, it violates the constraint of uniqueness, because uniqueness defines that no 2 rows can have the same value for the column. But primary key won't allow null values. Second thing is that a table can have more than one unique key, but there will be only one and one primary key in a table. Then we discuss about foreign key. In foreign key, we can create a relationship between 2 tables by means of primary key and foreign key. The tables which we are going to reference is called as a parent table, and the table in which we'll create a foreign key is called as my child table. I hope you all understand the various constants. And check again, specify a condition that must be satisfied by all row in a table. So again, these are the various examples. So if you'll see in the first example, they have created an employee table, and while creating the table, we are providing the keyword primary key. So we are creating the primary key while creating the table. But in the second example, we are adding the constraint to an existing table. We've already seen through the example or the key, the syntax. So we have to write alter table, name of the table in which we want to add the constraint. We have to provide the constraint by using add keyword. So we are writing add constraint. Name of the constraint is mandatory if we are adding the constraint to an existing table. What kind of constraint we are adding? So this keyword, for example, here, if I'll add foreign key, then it will add a foreign key constraint. If I'll add a unique key, then it will add a unique key constraint. So as of now, we are creating a primary key constraint. Then I have to explicitly define what kind of constraint I am adding to existing table. And in the last, as you can see, it is not only we can create a constraint to an existing table, but we can remove the constraint from an existing table. As you can see, the syntax is straightforward. You have to write the keyword alter table, and then we have the name of the table followed by the keywords drop, constraint, and then which constraint we want to delete. So guys, it is very important that when you are creating or adding a constraint, you should give a meaningful name to it, so that it will be easy for you to understand what is the name of the constraint. So if you want to drop that constraint, it comes handy, because we have to provide the name of the constraint which we want to delete. So I hope we are clear with the constants, various constants. We have discussed not null, unique, primary key, foreign key, and check. We have seen that we can create those constants while creating the tables, or we can add to the existing tables. And not only we can add, but we can drop the constant from the existing tables. The last topic for this module is view. As you can see, a view is a named derived virtual table. A view takes the output of a query and treat it as a table. So view basically, it takes the, just focus on this line, it takes the output of a query and treat it as a table, but it is not a table, it acts as a virtual table. So we can create a view from a single table, or we can create a view from multiple tables. So I'll show you how we create the views from multiple tables in module 3 when we'll discuss about the joins. So before creating views from multiple tables, we first need to understand what join is and how we can, join more than 2 tables. So as of now, I will show that how we can create a view using a single table. The syntax is straightforward. We have to just write create view, name of the view which you want to create. Just focus on the keyword, guys. We have to write as keyword and select, and then start from which table you want to include. Okay, so let me show you one example. Here's right, create view. Guys, as I mentioned that the SQL is not case sensitive, but sometimes as a naming convention, we provide, caps for our reserved keywords, so that, we know that these are the reserved keywords. So you can follow the same naming convention if you wish. Create view followed by the name of the view. So as of now, I'm creating a test view. and then as select start from and name of the table. For example, let's say I'm creating a view from employee table. Yeah, it's completed successfully. And in order to see the view, I have to first go and refresh my database. And guys, there's separate categories for views. We have separate categories for tables. We have separate categories for programmability. Under programmability, we create stored procedure functions. So this we are going to discuss and triggers in the last module. So we have a separate categories for most common database objects. So in order to see the view which we have created just now, we'll see, okay, see the view has been created, DBO test view. And if I'll expand this, guys, I'll see that this view has 3 columns, employee ID, last name, and first name, because we have created a view from employee table. So employee table has 3 columns, employee ID and name, FName. If we do not want all columns from a table, in that case, guys, we have to explicitly provide the name of the columns. For example, I just want only employee ID and L name. I don't want first name while creating the view. So if I'll create a view now, it is basically having employee ID and the L name from employee. So if I'll execute this, we'll go ahead and create another view, but this view will now be having the selected columns which we provided while creating the view. And you see, it has only 2 columns. So it is up to us how many columns we want to define in a view. A table can have like 100 of columns, but if you want to have selected columns, few columns in our view, we can do that. So view is a virtual table. We create view, for example, we need to write a query quite often. We are using that query quite often. So we can, instead of writing that query every time, we can create a view, and then view can act as a virtual table, and we can query the view the way we query a SQL table. So DDL commands basically define the schema of database objects, and DML commands basically helps us to manipulate the data in the database objects. So the important DML commands are, or the most common DML commands are insert, update, delete, and select. Let's first discuss about the insert statement. So insert command is used to insert data or record in the database table. When we create a table, the table is blank. There is no data in it. It has only the schema of the tables. What are the columns we have defined and the constraint of the tables. So very first thing we have to do is that we have to insert some record in the tables. So there are 2 basic syntax of the insert into statement which we use to insert records in the table. The first one is insert into name of the table in which we want to insert record, followed by the column names. We assume that these are the field names or column names. So sometimes we refer the columns as a field also. So after table name, we will define what are the columns in the table. Then we define the keyword values and the values of the corresponding columns. Important part here is that the order in which we define the column here, the value should be in the same order, or else we will get an error while inserting the record in the table. So let me show you one example. I'm increasing the font size for better visibility. Let's assume we have a table called department 1 here. So we are using employee DB database here. Good practice to use it upfront, that which database we are using for our queries. I'm using EMP database. So I'm using the first statement in my query window. Then I'm writing insert into department 1, department number, department name, values 20 and HR. So these are the values I'm going to insert in. So this is the syntax: insert into name of the table, followed by the column names. Then we'll use the keyword values and followed by the values of the column which we are going to insert. So let me execute this command. So as you can see, 1 row affected means we have inserted the changes. So in order to see whether the record has been inserted, you need to fetch the data. To fetch the data, we basically use the commands, but we will discuss about the select command in the coming slides. You can right click the table and you can see select top 1000 rows. So as you can see here, we have inserted the 9th record with the department ID department number 50, and the department name HR. This is what we've inserted into. So if I will change the order, let's assume I've changed the order and I'll make it 70. So I've changed the order of the values. The order is not the same as I have defined the columns. And if I'll execute this query, let's see what happened. We'll get an error because of the mismatched data type. So department number is basically numeric and department name is character type. So what we are going to do, since we have changed the order of our values, so we are trying to insert string or character data into numeric. So that is why we are getting this error. So the important thing is we have to take care about the order of the columns and order of the values while inserting the record. So this is the first syntax that we need to provide the name of the columns. The second syntax is if you want to insert the data in all the columns, let me show you on the slide. So we can see insert into departments. This we have discussed. So if you want to insert values in all columns, then no need to specify the column names, but order of the column values should be in sync with the column names. That's what we discussed now. So there are two different syntax. One, we need to define the columns, or we can skip the column names. We can directly mention insert into table name and the values here. So if I go here, I can say insert into department 1, and then I can directly write what values I want to insert. Let's say I want to enter the department IT and the location Mumbai. So again, the insert is successful. The one important thing here, guys, have you noticed that when we are inserting the record, numeric records, we are simply writing it, but when we are inserting string or character, then we have to enclose this in single quotes. Since IT and Mumbai, these are the string values which I'm going to insert into the columns. So the columns are location, department name, and department number. Department number is numeric, so I'm not enclosing this value in single quotes, whereas department name and location is variable length character, so I need to enclose the string into single quotations. If I'll try to insert the record without the quotation, I will get an error. Let me try to insert this, invalid column name. So please take care of this. So for string data or character data, we need to enclose this in single string. Another important insert command is insert as select statement. So far we are inserting the data in table, but here using insert as select statement, we'll insert the data in the table, but the data will come from another table. So using this commands, records from one table will be inserted in another table. As you can see the syntax, we can insert into the table name followed by the column names. What are the columns names which we want to define? Then we need to select the columns from an existing table. So we are defining select column names from table name where condition, and then this is the syntax. So let me show you the examples here. So for example, I'm inserting the values in department 1 table. So I'm defining what are the columns which I want to insert into. So these are the columns. So we have department number, we have department name, and then we have location. And then if I want to insert all the columns, so I can define the star here followed by the column name, department. So if I'll execute this query, I can see there were 4 records in the department tables. So if you'll see in the department, if I'll execute this query, select top 1000 queries, I can see there are 4 records. That is the reason when I executed this command, I got a message 4 rows affected. So what we have done in this query is I have inserted all the records from department table into department 1 table. If I don't want to insert all the records, then I have to specify a where condition here. So if you see, for example, let's assume this is my table and I want to only insert those records who's having department number greater than 20. In that case, I have to write where department number is greater than 20. If I'll execute this query now, see, only 2 records are affected. Why? Because we have only 2 records which is satisfying the conditions of department number greater than 20. So if I'll go and see the department table, I can see all the records has been inserted. In the last, we have inserted 30 and 40 because it is satisfying the condition that department number is greater than 20. So if we want to insert all the records of one table in another table, then we have to skip the where command or the where clause. If we want to insert a specific rows, specific records, then we have to filter those records using the where clause. Another important thing here is, it's not that we have to always insert the values of all the columns. I can skip or I can selectively insert the values for a column. For example, I don't want to insert the value for location. I can skip it. But here also, instead of star, I need to define which are the column I'm selecting. So I have to define department number and then department name. Again, the important part here to notice is we have to consider the same order of the columns. Since we are inserting department number and department name, from the second table also we need to arrange the column in the same order. So if I execute this query, it will execute successfully. All the 4 records are inserted into department 1 again. But if I change the order and if I'll execute it now, we'll get an error, the same error, the data types mismatch. So be careful whichever insert syntax you are using, whether you want to insert one table record to another table or you are inserting only directly the table, the order of the column is very important. Another important part here is that when we are inserting record in a table, we have to ensure that we'll always select all the columns which are not null. If you remember, in the previous module, we discussed about the not null constraint. Not null constraint defines that value in the column should be mandatory. So when I'm inserting a record in a row, I have to provide the value for all the columns which are mandatory. Let's take this example. In the department 1 table, we have department number as a not null, department name as not null, and location, that is LOC, is null. So in this example, I have not provided LOC, but still I am able to insert the record. But if I'll skip the department name and I'll consider LOC for insertion, and even though I'll maintain the same order of the column, but I will get an error while inserting the record. See, cannot insert the value null into the column department name. So department name is a not null column. When we are inserting the records, we have not specified department name column. So if we not specify, so the null value will be inserted in that. And since the column has a constant of not null, it won't allow us to insert the record. So we have discussed about insert statement. So these are the very important DML commands, because without inserting records in the tables, we cannot update those, we cannot delete them, we cannot fetch them. So insert statement is the main DML commands, as it helps us to populate our database objects with some data. Database is not static. It's not that we insert the data once and then we are done. No. Data needs to be modified as and when required, as and when there's a business requirement. So we use update statement to modify the data. Update statements modify the existing data in the tables. Using these statements, we can update the value of a single column or multiple columns in a single statement. We have the choice whether we want to update the value of a single column or whether we want to update the values of a multiple columns, and this can be executed in a single SQL query. We don't have to write multiple queries for each and every column. When we update the records in the SQL table, it is very important that we should provide the condition that which records we want to update. If we fail to provide the condition, then all the records in a table will get updated. So whenever we are updating the records, it is very important for us to define the condition. As you can see in the notes, without where clause, all the rows will get updated. So let's see one example. Let me open another table. So I have department 2 and I can see there are 4 records in it, and I want to update the department name of the department number 30. As of now it is IT and I want to change it to marketing. So we have to follow the syntax update. Let me copy it so we can save some time. So we have to set the department name and we want to set the department name to marketing. So I have to define the new value which we are going to update, and we have to update the value of department name for the department number 30. So I need to mention that in the where clause. So let me execute this query. As you can see, 1 row affected. It means the update has been done and it is successful. So let me again see the records. So we have updated department, not the department 2. So I have updated the wrong table. So let me execute it again. Again 1 row affected. And if I'll execute this select top 1000 rows, I can see that the department name has been updated. I was talking about the where clause. That where clause is very important while you make any update statement. So let's assume we forget to include. So this is how, guys, if you want to comment anything, you can do hyphen. So the green part here in the query is that it is commented, or you can write /* and then star followed by /. This is how you can add comment in your SQL queries. We'll see the use of these comments when we'll discuss about functions and modules, when you have to write some comments so that other developers can understand what you are writing. So to add comments in SQL queries, either we have to follow this syntax or we have to write /. So if I'll skip the where clause in the update statement, let's see what happens. Can you see 4 rows affected? There were 4 rows in the department 2 table, and while updating, when we skip the where clause, all the records get updated. So can you see the department name for all the rows has been updated to marketing. So it is very important that while we are updating, we have to specify the where clause, or else all the records will get updated with the same value for a particular column which we are updating. So in this example, I have updated the value of a single column, that is department name. But in single SQL query, we can update values of multiple columns. Let's take the example. So in the department 2, I am just updating the values of department name to marketing, and I'm updating the location to Chennai, and I'm updating it for only department name number 30. So in a single statement, I'm trying to update department name and location. Query has been executed successfully, and if we'll go and see the record now, 30 has been updated to marketing. So maybe to remove the confusion, what we can do, we can update it with some other value. Let's say it's HR, and we execute it again. As you can see, since in the where class I have mentioned department number 30, so I have updated the department name and location in a single update statement. Whether we insert the record in the table or whether we update the records in a table, the data type plays an important role. We have to always update the data as per the data type of a column. If I'll try to insert, let's assume that I'm updating the department number. So let me write one more query. Let me first increase the font. Let's assume I'm updating the department number, and instead of a number, I'm trying to update with string or character. So I'm trying to update the department number 30 with value HR. If I'll execute this, it'll give me an error, that error converting data type varchar to numeric, because department number it has a data type numeric, and I'm trying to insert string or character in the numeric data type. So irrespective of whether we are executing update statement or insert statement, we have to always take care about the underlying data type of our fields or columns. Now we'll show some lights on delete statements. So delete commands helps us to delete row or records from the database table. Similar to update statement, delete statement can be executed with or without where condition. But again, point here to be noted is that if we will execute the delete commands without where condition, then all the records or rows from the table will be deleted. So where clause is very important whether we are working with update statements or delete statement. So if we purposefully want to delete all rows from our table, then of course we won't include the where clause. And if you want to specify whether it's not a single row but multiple rows, but if you want to not delete all the rows, then of course we need to include the where clause. Let me show you a few examples. Let me open a new query. So let me first show you what all the records are there, and we'll try to delete those. So will be deleting the record with department number 40. So one row is affected means the query has executed successfully. So if I'll go ahead and execute this again, I can see only 3 records because the desired record has been deleted from the table. Now, if I will skip the where clause, so I'm commenting the where clause by adding 2 hyphens here. As discussed, we can add the comments by using either hyphens or using /* and then again /. So if I execute this query now, can you see in the result 3 rows affected? So after deleting the department with department number 40, we had only 3 rows and all 3 rows has been deleted. So if I'll query the table again, it's empty. Now there are no more record in department 2. So that is the reason it is very important to include where clause in the delete. When we add the condition in the where clause, it can be like single conditions or multiple conditions. We'll discuss that how we can add the logical operators and how we can use the or conditions or and conditions in the where clause. So far we have discussed 3 important statements for DML data manipulation language commands: insert, update, and delete. Now we will be discussing about the select statement. So far we have discussed that how we can insert the record, how we can update the existing data, or we can remove the unwanted data from our database, but how we are going to fetch the information from our database and show it to the end user is very important. In this module, we will be focusing only on retrieval from a single table. In the next module, we will be discussing about retrieval from multiple tables by means of joins. Where condition is optional in select statement. So as we discussed earlier, where condition is always optional, whether it is update statement, delete statement, or select statement. So we have to be very careful while using where conditions. It's up to us that whether there's a business requirement to include the where clause or not. When we use where conditions, there are various operators which helps us for the better retrieval or better condition. So to retrieve the data, we use select statement. As you can see the syntax, select field 1, field 2, field n. These are the various columns. From table name, which column we want to include for data retrieval, and followed by a where clause, which is optional. Let's see one example of the select statement and then we'll move to the next slide. Let's assume I want to select the records from department tables or employee table. Let me write the query here. Let me delete the previous query. So select statement helps us in data retrieval. If we want to include all the columns of a table, then we have to use the star or asterisk sign. So this is the basic syntax of a select query. asterisk helps us in retrieval of all the columns. So I'm writing select star or asterisk from employee. As you can see, all the columns of employee table are there in my result set. Let's retrieve some other table. Let's retrieve department table. Again, I want to retrieve all the columns. So I will write select star from department. Since there are only 3 columns in the department, I can see all the 3 columns are here. And there are only 4 records. So all the 4 records are displayed. Why 4 records are displayed? Because we have not included any where condition. We are telling SQL Server that we want to fetch all columns and all rows. So if we'll skip the where clause and we'll add a asterisk in our select, it means we want to fetch all the columns and all the rows in our result set. One important thing that, for example, I'm querying 2 different tables as of now. So it is not that at any given point of time, I can fetch only values from single table. If I click on execute without selecting any particular SQL query, I can see the result set of both the SQL queries. So though where condition is optional, but it is very important to include where clause in SQL queries to set a right condition so that we'll get the desired result, or else we will get all the results or all the rows. In real world scenarios, we have millions of records in our database, or generally thousands of rows. So if you forget to add the where condition, think about the number of records you will get, and it's very difficult to get the right results. So it's very important to include where condition, whether you use update, delete, or select statement in DML commands. As of now, since we have not included where clause, but even without using where clause, we can filter the number of records which we want to include in a result set. So we have a keyword, a reserved keyword in SQL, that is top. Let me show you one example of that. So though I'm including all the columns by using asterisk sign in this query, but I'm explicitly telling to the SQL Server that I want only top 3 results to be included in my result set. So if I execute this query, I will get only 3 records. So we can define, we can change the values. In this example, I've shown only top 3. We can include top 5. We can include top 1. I can confine or I can restrict the result set, but again, it will be only from the top 5 or bottom 5. So we cannot replace the where clause or the where conditions by top 5, but top 5 helps us to retrieve only selected portions of our data in a result set. So far we have discussed that we can use asterisk signs if we want to include all the columns in our result set. But in the practical scenario and in the real time, a table may contains hundreds of columns, but we might not be interested in getting values or fetching values for all the columns. We might be interested in few columns. Then yes, we can include selected columns in our select statement instead of star or asterisk. Let's see one example. So as of now, as you can see, we have 9 columns in the employee table, but I want to see only the first name and last name of the employee. So instead of writing star or asterisk, I can mention select first name followed by comma, last name from employee. So I will get the results only for 2 columns. And again, if I want to restrict the results, so I can use stop even with the selected columns. So this will show me only top 5 records in the result set. So when we are retrieving the results, if we want to include all the columns, then we'll use asterisk. If we want to include selected columns, then we have to specify the name of the columns, and all the columns should be separated with each other by comma. And the order in which we specify the column names in select statement, in the same order we will get the columns in the result set. Since in my result set I'm getting first name as the first column because I have defined the first name in the same order in my select statement. In select statement, we can use alias name for a field or a column. Please don't get confused between field and a column. Field is used for the column name of a column in SQL. Why we use alias? Let me show you. Let's take the example of department table. As you can see, we have LOC for the location, but maybe it is not clear to some developer what LOC stands for. So I can change LOC to location. So for that, we need to use alias in SQL. So how do you use that? Let me show you. You have to write select department number, LOC. We have to use as keyword and we have to define the name of our column, location from department. If you'll see, I have used an alias location for the LOC column. So to increase the readability of columns, we use alias. Sometimes main use of alias is in inner joins. So when we'll discuss about joins in the next module, I'll revisit this particular topic and I'll explain you. Sometimes the column name, table name is very long, so we can use alias for column as well as for the tables. As of now, I'm showing you example for the column, but we can use alias for tables also. It is not that we have to use alias only for a single column. We can use it for as many as columns in our select statement. Even we can use for all the columns which are there in our select statement. So to sum up, alias helps us in better result sets. It makes result sets more readable for the end user or for developers. Let's move to the next slide. Distinct values. A column can have the same values if it is not primary key. So as we discussed in the previous modules, a primary key or a unique constraint, these helps us in maintaining a unique values for each row for a single column. But other than unique and primary key, we can have multiple values for the same columns in different rows. Sometimes when we are retrieving, we are more interested in only distinct values. In that case, we'll use distinct keyword to filter our result in such a way that it will only retrieve the unique values for a particular column. So let's understand it using one example. Let's take the example of department 1 column. As you can see, I have Chennai at different places for locations, and I want to know that in which location my department is. And I want only the unique values. I don't want the repeated data or redundant data in my result set. So for that, what we can do is that we can use unique keyword while fetching the data from tables. So we use order by to show the results or to filter the records. So far we have discussed about the unique or distinct keywords in the select statement. Now we'll see how we can sort the data. So for sorting, we use order by. So order by is used along with the where clause to display the specified column in ascending order or descending order. By default, the order is ascending order. If we won't provide any specific keyword, the result will always be in the ascending order. So order by is used along with where clause, but it is not a mandatory condition that we have to use order by only with the where clause. So let's see one example. Let me write a new query. So we have select star from department. Let me increase the font. Select star from department, and then we can use order by. So we have department. So since I have not provided any keywords here, so by default it will be ascending, or even I can provide ASC. ASC stands for ascending. So if I'll execute it now, I can see the results, same result. But if I change the keyword ascending to descending, descending stands, DSC stands for the descending. So if I'll execute it now, I can see department in the reverse order. So the result set has been reversed. So this is how we can sort our records in a result set. So in the previous slides, we have discussed about the top 1 or top 5, top 10. So we can club top keywords along with order by to fetch the bottom records. we can filter or we can fetch the bottom 5 records or bottom 10 records, because there is no reserved keywords for bottom. We only have the keywords as a top. So if I want to show the bottom 2 records, let's see how we can club top with order by to fetch the desired results. So first of all, I'll show you the results without using order by. So I'm just showing you top 2 results from department column. And in the next query, I will write select top 2 start from department, and I'll write order by department number. If I'll execute both the queries, you will see the results. In the first, since we have not used the order by in the descending order, I'm getting the top 2 records. But in the next result set, since we have used order by along with the top 2, we are getting the bottom 2 records. So this is how we can, use various concepts in our select queries to get the desired result set. So we have discussed the sorting, that how we can sort the data. As you can see in this example, we have used multiple columns in the order by. So it is not that we can use only one column in the order by. We can include multiple columns, but the results will be sorted in the order in which we have specified our columns. So since we have specified department name first and the order is ascending, the result set will be first sorted by department name column. So yes, we can include multiple columns in the order by clause. Let's move to the next slide. Filtering. So far we have discussed that how we can insert the data and then updation of data using update statements, then delete statements. And we've discussed about the select statement, top 5, bottom 5, how we can include all the columns in our query or result sets, or we can include selected columns. We have seen that by order by clause, we can sort our data. Now we are going to discuss about the filtering. So far, whatever examples we have discussed about the select statement, we have not included where clause, since where clause is optional. But if we will not include where clause in our SQL queries, then we are going to get all the results, which is not a good idea, because your database or your table can have thousands of records. So it may impact the performance also, that when you are fetching all the records in one go. So we use various conditions in our SQL query while fetching the data. So we use where clause to narrow down our result. So in the where clause, we use various operators. We use comparison operators, we use logical operators. So there are 3 main logical operators: AND, OR, and NOT. So we'll discuss AND operator first. So AND logical operator used to combine 2 conditions, and it fetches the result which satisfy both the conditions. So instead of writing 2 different queries, we can club the 2 conditions in one single query. And if our query will satisfy both the condition, then only those records or those rows will be shown in our result sets. Let's see with an example. Let me first show you all the records of the department table. So we have 4 records, and let's assume we want to filter the record which has department number 10 and along with one more records which has department name HR. So what we can do, we can use select, since we are including all the columns, select star from table name department, and now we'll use the where clause. So we'll use where keyword, where department number is equals to 10, followed by the AND keyword, and department name is HR. Please pay attention that we should not use double quotes. We always use single quotes in SQL. So like other programming languages, C, C++, C#, Java, where we use double quotes for string, here we use only single quotes, whether it is a character or a string. So if I'll execute this query, it is not showing me any results because it is not satisfying any condition. Why? Because there is not a single row which is having department number 10 and department name HR. So if I'll change it department number to 20, then it will satisfy the condition. The second record will satisfy the condition. So that's what we have discussed, that if it will satisfy both the condition, then only the rows will be displayed in the result set. Now if I'll execute this query, we'll get the desired result. This is how we use AND logical operator to get the results or get the desired rows in a result set. So again, let's see this example. So in the first example, we mentioned that we are fetching the selected columns. We are using select first name, the last name from employee table, where first name is equals to Miller and last name is equals to Ward. This is how we are getting the result. In the second example, we are fetching that show the first name, department name, and salary from employee table, where salary is greater than 20,000 and salary is less than 35,000. So we can use multiple conditions, and only those records will come which will satisfy both the conditions. Let's move to another logical operator, OR. Like AND operator, OR operator is also used to combine two or more conditions. But the main difference is that it will fetch the results if any one of the conditions is satisfied in the OR statement. So let's discuss it with an example. Example we discussed, when we made it to 10, we got the empty result set because no row is or satisfying both the conditions. But if I'll replace AND with OR keyword, we'll see both the rows. So the main difference between OR logical operator and AND logical operator is that in AND it has to satisfy both the condition, whereas in OR, if any one of the conditions satisfy, we'll get the rows or record in our result set. So based upon the business requirement, we use either AND or OR logical operator. Now we'll discuss the last logical operator, NOT. So NOT operator is basically used to negate the condition. So it basically fetches the opposite of the results, which is basically defined in the conditions. So it is also used in combinations with another keywords like not in, not between. So as you can see in this screen, we are using select department name, location from department when location not in Chennai and Bangalore. Let's see this with an example. So let me show you first all the records so that we know what we are querying. So let's assume that I want to get all the departments which are not located in Hyderabad. So I'll write select star from table where column name, not keyword because we are looking for a negation, not in. We'll discuss about in operator in a meanwhile. Let's execute this, and here we go. So now since we want all the departments which are not in Hyderabad, so we use not logical operator in a negative sense, and we are getting all the records other than Hyderabad. So this is how we use not operator. So for filtering, we use logical operators as well as comparison operator. So far we have discussed three important logical operators, AND, OR, and NOT. We use AND and we'll get the desired result if it satisfies both the conditions. We get the results set if it will satisfy any one of the condition if we use the OR logical operator, and NOT logical operator is used in negative sense or to negate the conditions. So let's move to other operators like comparison operators. So we have various comparison operators which we can use in the where clause or where conditions to filter our results. We have equals to followed by a not equals to. We can use either exclamatory sign and equal to for not equals to, or lesser than greater than sign in combinations for not equals to. So we'll get the same results. We can use either one of them. Then we have greater than and equal to, less than equals to, like operator. Like operator we generally use when we use or play around with the strings or characters. We use between operators when we want to find or when we want to fetch the results from a range. In keyword we just saw an example. So these are the various comparison operators. Let's start with the between operator. So the between operator is used to search for values within a set of values. So let's see this example. So we are fetching the details of employee whose salary is basically between 2,000 and 35,000. So let's see with this example. Let me open a new query. So we are going to fetch the employees. So let me first increase the font size for better visibility. So now I want to fetch the records. So salary is greater than 20,000 and less than 35,000. So I'll do that. I'll write select star from employee where salary between 20,000 and 35,000. So between operator is always used in combination with and operator. This is how I get the result. So there's only one record which is satisfying these conditions, this one, Smith. So this is how we are getting the desired row in our result set. So it's basically used for a range. So you can use between operator. Let's move to the next operator, not in. We've already discussed about the not in. So not keywords is basically logical operators, and it is used along with other operators like in and other. So we have just seen one example where we want to show the departments which are not in Hyderabad. So this is the repetition of the same example. In the previous example which I shown, I included only one locations, but we can use multiple keywords if you're using the in keywords. We'll see the example just now. In operator fetches values from a set of literals. So this conditions is generally used when we want to fetch values from multiple values in a single statement. So it's not that I can use only in, I can use or operators. So if there are only one or two conditions, I can either use or operator or in operator. But if the values are more, it is not a good idea to use so many or operators or logical operators. Let's assume I want to see the results in 10 cities. So if I write like where location is equals to Mumbai or New Delhi or Hyderabad or Bangalore or Chennai, it is not readable. It's not good. So instead of writing so many or operators, we can use in operators. So the in operator, we basically include all the values out of which we want to filter our results or we want to fetch our values. So let's see with an example. So let me open a new query window and write select from department. So if I want to see the results or see the departments which are either in Chennai or Bangalore, so I'll write select star from department where location in, it can be in any one of these locations. That's how we are Bangalore. Don't forget to include strings or characters in single quotes in SQL. So this will fetch the desired results. So we can use multiple values in the parenthesis if we use in comparison operator. So if I use not in, then this will go in a negation and will show the opposite of what in operator is doing. So we have discussed not in as well as in. So if there are multiple values, so instead of or, we have to use, it is good practice to use in keyword. Then basic comparison operators, we have greater than, equals to, less than, greater than, equals to. So this is pretty much self-explanatory. So if I want to select the employee whose salary is greater than 20,000, so let's see how we'll get the results. So I can use the previous window. So where salary, instead of this, I can write salary is greater than 20,000. So I'm getting 3 results. So I have 3 records or 3 rows or 3 employees whose salary is greater than 20,000. So if I include greater than or equals to, then I guess I'll get 4 results. Oh, I don't think so. We have a salary of 20,000 here. No, we don't have. So let's take the example of 30,000 here. So we'll get the 3 results. But if I remove the equals to keywords, then of course we'll get only 2 rows in the result set. And if I use the equals to, then we'll get the only single row which will satisfy the desired or required condition. So this is how we use a various operator: greater than, equals to, less than, greater than, equals to. Again, this example, we can use equal operator. It will satisfy the desired conditions, fetch the results. Comparison operator is the like, how we use the like keywords in comparison operator. So generally we use like operators to perform wildcard searches of valid search string values. As I mentioned earlier, that like keyword is generally used when we are filtering or fetching the strings. So it used with two wildcards. One is percentage. Percentage denotes 0 or many characters, and underscore denotes 1 characters. So let's see. So in the first example, as you can see, I'm getting the values from the department table whose locations starts with C or the C alphabets. Let's see how we can use it. So we'll first see how we use the percentage wildcard. So if I want to know that what are the different departments where the locations start with the alphabet C. So we'll write select star from department where LOC. I have to use the like keyword, like parenthesis, and then the keyword C with a percentage sign, that is wildcard, and get the results. So if I'll just change the order, if I'll write the wildcard first and then C, it means I have to show the departments whose location ends with C. So if I'll write it I here, then again I'll get the desired cell because I'm fetching the rows whose location ends with the I keyword or I alphabet. So if I'll use first wildcard and then alphabet, it means it ends with. If I'll first use the alphabet and then wildcard, it means it's start with. If I'll write something like this, it's C, then wildcard and I, it means it starts with C and it ends with I. So fetch me the locations who start with C because I'm using the C before the wildcard, and since I'm using I after the wildcard, so it ends with I. If I'll execute this query, again it will show me the same results because, but if I'll change it, for example, I'm starting with H and ending with I, so there is no department with such a condition, so it'll get an empty result set. Now if I need to show that, show me the department who starts with H, in that case all I have to do is that we have to remove the I. So we have to use the keyword before the wildcard and it will show us the result. So along with percentage signs, we use underscores also as a wildcard. So in this example, as you can see, the second example, select department or location from department where locations like. So it means the first three words should be CHEN. Then we can use underscore. So we have to first satisfy the first keyword. So the first three should be this. So this is how we use the underscore wildcard. The last topic of this module is the case expression. So case expressions helps us to kind of simulate the if then else statement. Like in most of the programming language we use if else. So this helps us to write the same. Only point with a case statement is that, as you can see in the note, we cannot use null values in the case statement because it always uses the equals to operator. And we cannot use equals to operator with the null keyword. We have to use is null, that I'll show you after this example. So let's assume I'm fetching values from employee. So if I'm looking for the salary column, there are a few rows which are having null values and there are a few rows which are having values in it. So if I want to see that what are the different employees which have null values for the salary column. So if I'll try to write where salary equals to null, then I won't get any result here because equals to operators does not work with null. So if I'm checking null, we have to use is null. If I'll execute this query again, I'll get the desired result. If I want to check, if I want to fetch the columns which do not have null values for the salary column, then we have to use is, and then we have to use the not logical operator, is not null. So not logical operators is always used in combinations with other operators. We get all the employees do not have null values for the salary column. So that is the reason we are using case expressions, so we cannot use the null values, otherwise it will break because we use the equal to operators and equal operators is not used along with null. So this is how the syntax of case expressions. As you can see, we have declared a variable int input, its type of int, and we have set the values is equals to 2. It's just an example. So we have hard coded the value here in this example. So we are selecting case. I'm just selecting that if the value is 1, then we'll show the output as 1. When it is 2, then we'll showing the output as 2. When it is 3, then we are showing output as a 3. And if it is not out of any these three values 1, 2 and 3, then we'll show the message as your message. This is how we are doing in this example. So let me give you one example for that. Let me do one thing. Let me find out the states or the cities where my department is. So as we know that Chennai is in Tamil Nadu and Bangalore is in Karnataka. So let's see how we can do that using a case statement. So we have to write select, then case keyword. In the case keyword, we'll define which columns we want to fetch. So I'm fetching the location, and then we'll write the when condition. So I'm writing when Chennai, then show the result as Tamil Nadu, when Bangalore, then let's say Karnataka, and I'm writing an else condition if it is not part of anything. So let's write no idea. So we have to end the when condition, and we have to write from which tables we are basically fetching this results. So if I'll execute this query, I'll get, see, if it is Chennai, I'm getting the result as Tamil Nadu, and if it is Bangalore, then I'm getting as KR. And since there's some departments which do not have any values like Hyderabad, so we're getting is just no idea. So this is how we can use if else conditions in SQL statement or select statement by using case expression. Important point is that we should not deal with where we're using null because we use equals to operator. A join clause is used to fetch data from two or more than two data tables based on the join condition which we'll provide in the SQL query or SQL statement. Join clause is used to combine rows from one or more tables. When we say one, means if we're trying to join a condition on a single table, then this particular condition is called as self join. So these joins basically happens or takes place between tables based on the common columns between them. In SQL Server, we have the following joins. We have self join, we have inner join, left join, right join, and full after join. Cross join is also called as Cartesian products. A table can be joined to itself in a self join. The important part here is that when we will use the self join, then we have to use the table alias because our table name is same because we are making a join on the same table. So if you'll see the syntax in the select statement, we will mention the columns which we are trying to fetch from the tables. Then we have a keyword from which table we want to fetch, and then the table alias T1. Then we'll join another table name because the table name is same. That's why we have to use another alias for the same table, that is T2. And then we will provide a join condition with on keyword. We'll mention T1 dot column name equals to T2 dot column name. So this syntax will be more clear when we will show some examples of self joins and other joins. So this is an example of a self join where we are joining the same columns. So we will see this example. We'll execute this example in the Management Studio, but before that we'll discuss other join as well, and then I'll show you the examples for self join. It is not that we quite often execute self join. We execute self join only in some rare scenarios. Most of the time we try to join two or more than two tables. So we have inner join. The inner join fetches the records that have matching values in both the tables. So that is called self join, or sometimes we call it as simple join also. So here is the syntax for the inner join. We write the select statement followed by the column list. We mention the from which tables we want to fetch the informations, and then we provide the table alias. It is not mandatory to provide the table alias, but it is good practice as sometimes the table name is very long, so we don't have to write the table name always. So to avoid this, we provide small table alias, which will helps us to identify, which helps us to fetch the columns in the select statement as well as in the on condition. So let's see an example of inner join first. So let me close all these windows which are open in Management Studio. So for join, we will be using these two tables. We will be using employee table. Let me show you the data of the employee table. This is our first table, employee table. So we have the following records in it. We have 6 rows, and the column is employee ID, first name, last name, and address. In the address, we have the city name. For the 5th record, we do not have the value for the address, it is null. The other table which we'll consider to show you the examples is orders. In the order table, let me first execute the single statement first. So this is the order table. We have 5 entries, so 5 records in it, and the employee ID is null for the order ID 5th or for the 5th record. Let me execute these two statements together. So if you'll see, my orders table is the child table, whereas the employee table is the parent table. Employee ID is the primary key and order ID is the primary key in this table. And these two tables are joined by employee ID column. So when we join two tables, there should be one common column, or there should be some matching values in both the tables. If there is no matching values in parent and child tables, or two tables in which we want to apply joins, then there won't be any result in the result sets. So the basic prerequisite is that the two tables which we are going to join should have some common values in between them. So let's take an example of inner join now. We are clear with the two tables. So this is the syntax. In the select statement, we'll provide what are the columns which we are going to fetch. So in this example, we are fetching 3 columns, 1 column from employee table and 2 columns from the orders table. So that is the reason we have explicitly mentioned the table name, then dot, followed by the column name in it. So when we use joins, it is important to provide the table name before the column name. Let's assume what will happen if I'll remove the table name. See, the moment I remove the table name, I'll get an error that the ambiguous column name employee ID. Why ambiguous? Because if you'll see, we have employee ID column in employee table as well as in the orders table. So if we will not provide the table name, then it is difficult for SQL Server to identify that which column we want to fetch, as the same column may be present in both the tables. But if I try to remove this table, then I won't get an error. The reason is the order ID column is unique. It is present only in the orders table and not in the employee. But it is good practice that we will provide the table name in the select statement to avoid any such issues. I hope this is clear, that why we'll provide the table name before the column name in the select statement. Because if the column name is same in parent and child table, then it will throw an error and we won't be able to execute our SQL queries, because there will be an ambiguity for the same column name. If the column is unique and is not present in both the tables, then we have the options to skip the table name before the column name. So we'll provide the column names in the select statement. Then we'll first provide the name of our first table, followed by a keyword inner join. So based upon type of join which we want to create, we'll provide these keywords. If it is left join, then we'll replace inner join with the left join. If it is right join, then we'll replace inner join with the right join. So based upon the join, we'll replace these keywords. So as of now, in this example, I'm showing you the inner join example. So we have included the inner join keyword. So if you'll see, we are basically joining two tables. So one is employee, the other is orders. So first we have to identify which two tables we need to consider for join. In our case, we have considered employee, EMP table, and orders table. Now the second part of join is that how we want to join these two tables. As I mentioned, there should be some matching columns or matching data between these two tables in order to join them. So in both these tables, employee ID is common and it has the matching data. So we have to specify an on condition, and in the on condition I have mentioned that emp.employee is equals to order.employee, fetch me all those records, and then followed by the employee ID. As we discussed in module 2, we use order by keywords or order by clause to sort the data. By default, the sorting is in the ascending order. If you won't provide any keyword in the order by clause, it will be always be in the ascending order. So let's execute this statement first. Yeah. So if you'll see the table data here, we'll be getting only 4 records here because in the order tables, we have only 4 records for the employee ID. Though we have 6 records in the employee table and 5 records in the orders tables, but the matching condition is only for the 4 records or 4 rows in both the tables. So in the result, we will get 104 employee ID, 102, 105, and 101. Since employee ID 103 is not there in the orders table, also 106 is not here. That is the reason these 2 rows will be skipped from the result set. As you can see, there is no row with the employee ID 103 and 106. So in this example, the inner joining is returning all rows from the employee and order tables where there is a matching employee ID value in both the employee and orders table. That is the reason the rows where employee ID is equals to 103 and 106 in the employee table would be omitted since they are not present in both the tables. So the syntax which we are seeing as of now on the screen is the latest syntax or the recommended syntax or the ANSI standard syntax. But there is an older syntax where we do not use the on keywords, but still we can achieve the same result of join. Let's just have a look on the older syntax also, because some authors or some people use older syntax for the inner joins and other joins. But this syntax are not recommended, and if you're writing joins, you have to follow the syntax which we have discussed just now. So in the older syntax, we just mention the name of the tables, and the tables will be the comma separated. And instead of on conditions, we include the condition in the where clause, where employee.employee ID is equals to orders.employee ID, followed by the order by clause. So it is not that every time when we are writing joins, we have to provide the order by clause. Order by clause is always optional. So if I'll try to execute this query, I'll get the same result set. And if you want to change the sorting order, we can change it to the descending order also. So if I'll execute, the result will be in the descending order of employee ID. As you can see, 105 is on the top. Again, order by is always optional, and it is not mandatory to involve order by in inner joins or any other query. So inner join helps us to fetch the rows from both the tables which have matching value in both the tables. So that's why sometimes call it as equijoins or simple joins or inner join. So don't get confused between these synonym terms. Sometimes since we are matching the values which is common, people call it equijoins. It is the simplest of all the joins, so we often call it the simpler join or simple join, and technically this is inner join since we are using the inner join keyword to fetch the results. But in the older syntax, we do not use inner join keywords. It is good to know about the older syntax, but it is not recommended to use older syntax going forward. Let's understand more about inner joins by help of a Venn diagram. So just by looking at this diagram, you'll come to know So we have, for example, two tables, table employee and table department. As of now, I've shown you the examples from orders tables, but let's assume that we are joining two tables, department and employee. So in inner join, the values which is common in both the tables, so the intersecting part will be fetched in the result set. So better visualizations, you can relate inner join with this Venn diagram example. And if it is self join, then instead of these two tables, we'll join the same table. Now when we saw the example, when we see the syntax of inner join, see that we are using table alias here. But in our case, we haven't used any table alias. So using table alias is optional. If I want to change the table alias, then I have to do, for example, let's say I'm writing it as E for employee and orders for orders, O for orders table. In that case, since I'm using alias, I have to remove the table name and have to replace with the table alias. To sum up, if we use the table alias, then we cannot use the table name. We have to replace with the alias only. Not only the select statement, we have to use all the places. So it is not mandatory to use this. We can either give the table name or the table alias. Generally, we use table alias when there is a long name for the tables. Good practice is that do not provide the keywords like how I have done E and O. It has to be meaningful name. For example, let's assume the table name is employee information. So I can write the short form EMP info. Because just looking at the alias, we should understand that this alias is for this particular table. So if I'll execute this statement again, I'll get the same results. So if we are using self join, then it is mandatory to use the table alias because, or it is good to use, I would rather not say mandatory, it is good to use because we will be using the same table name. So if I'll be using the self join, then if I'll provide the same alias, I cannot use it because we cannot use the same table name in both the clause. So let's assume that I'll remove this table. Then we'll get an error because we cannot use the same table name in the inner join. As you can see, the objects EMP and EMP in the form class have the same exposed names. Use correlation name to distinguish them. So my first statement was right. Yes, it is mandatory to use table alias when you're using self join. So we can give it as E1 or we can give the same table, the other alias as E2. And I can replace it with E1, E2, and E2. So these columns are not there. So that is the reason it is giving an error. So we'll get the desired result. So this is how we create the self join or provide the syntax for the self join. So it is mandatory to provide the table alias in self join because we cannot have the same table name in the from class or in the inner join. I hope self join and inner join is clear. And let's move to the next slide. So this is again example of inner join before we move to the next slide. So in this we are joining the department table and employee table with the department number. So we have provided the table alias. For the department we provide the T1 and for employee T2. And when we are providing the columns in the select statement, then we have to explicitly provide that which column is coming from which table. So first name is defined in the employee table. That is the reason they have mentioned T2.firstname. And this is a good example. Here we are providing the alias for column name as well as table name. So alias is applicable for column name if you want to give a meaningful name for the columns. Because first underscore name, it is good to use in the backend. But if you want to show the results in the result set in the query window, or if you want to consume this result set somewhere in our programming language by means of AD.NET or any other means, then it is good to provide a meaningful or more readable name. So that is the reason we provide column alias. So let's move to next join, that is left after join. So left after join returns rows to the left even if there is no rows on the right of the join clause. So the left and right is basically decided by the arrangement of the tables in the on clause. So this type of join return all rows from the left hand table specified in the on clause or in the on conditions, and only those rows from the other table where the joint fields are equal or joint condition is met. So I repeat it again. As you can see in the point second, the result is null for the row on the right table when there is no match. So when we execute left after join, it will always fetch the values from the left table, and if there is no matching terms in the right table, then those values will be replaced by a null keyword. So the syntax of left join is almost similar to the inner join. The major difference is inner join is replaced with another keyword that is left after join. Here the left table will be T1 and the right table will be T2. So let's see an example of left after join. So here our left table is employee and the right table is orders. So if I execute this statement, this is the result set. So the left after join is basically returning all the rows from the employee table and only those rows from the orders table where the joint fields are equal or there is a matching condition. So if an employee ID value in the employee table does not exist in the order table, all the fields in the order table will display the null value in the result set. In this result set, the rows where employee ID is 103 and 106 would be included with the left after join, but the order ID and order date field displays null. So if you see the data, since we are using left after join and our left table is employee, so it will fetch all the 6 records 101, 102, 3, 4, 5 and 6 in our result sets, because we are fetching 3 columns: employee ID, order ID and order date. So left after join will include all the records from the left table. That's why we are having 6 records in the result sets. But if there is no matching values in the right table, so our right table is orders and order ID and order date are basically fetched from our right table, that is orders, and in the order tables there is no value for employee ID 103 and employee ID 106. If you'll see again in the orders table, we do not have any rows with the employee ID 103 and 106. So those values are replaced by null here. So that is the reason for employee ID 103, we have null values for order ID and order date, which is coming from orders table, and that is the right table in the left after join in this example. I repeat, when we use left after join, all the values from the left hand side table will be included in the result sets, and if there are no matching records for those rows in the right table, then those values will be replaced by null. In some databases, the outer keyword is omitted and we simply use left join. So in some database, instead of writing left after join, we simply mention left join. And if I'll execute the command again, I'll get the same result sets. So don't get confused between left after join and left join. It is one and the same thing. I hope left join is clear. Let's move to other examples. So this is one more example of left after join before we move to the next join. So here we have first name and department. These are from 2 different tables. So employee is our left table here and department is the right table. So we'll always get all the records from the left table. That is the reason, if you'll see, in the first name we have all the records, but in the right hand side, that is the department table, for the Miller there is no value in the department. There is no department number which is there in the employee table in the department table. That is the reason the value is coming as a null in the result set. So all the values from the left table plus all the values which have the matching values, and if there is no matching, then it will be replaced by a null keyword. So let's move to the right outer join. So right outer join returns the rows to the right relationship table even if there is no matching rows on the left relation table. It is almost similar to the left outer join, only the conditions is reversed. In right outer join, the result is null for the rows on the left table when there is no match. Whereas in the left outer join, the result is null for the right table when there is no match. If you'll see the syntax, the only difference here in the syntax is in the right join, we basically use right outer join as the keyword, whereas in the left outer join, we use left outer join as the keyword for joining. So right outer join returns all the rows from the right hand table specified in the on conditions, and only those rows from other table where the join tables are equal will be fetched. And as mentioned in the point 2, if there is no match, the result will be null in the result sets. Again, it is not mandatory to have the outer keyword. We can simply use right join as well. Don't get confused between right outer join and right join. These are one and the same thing. So let's see an example of right outer join or right join. In this example, right table is orders. So we'll get all the results or all the rows from the right table. So as you can see, I'm fetching. Let me first change the order by clause. Instead of employee ID, let me fetch it using the order ID. Order by order ID and descending. Let me execute the statement again. So as you can see, we have sorted this using the order ID, the result set. Since orders is the right table, we have all the records from the orders table, but since there is no matching records in the employee ID, we are getting it as a null value. So in this example, the right outer join is returning all rows from the order table and only those rows from the employee table where the join fields are equal. So it is almost reverse of the left outer join. I hope this is clear. So let's understand left outer join and right outer join by help of an diagram. So if you'll see, this is example of left join example here, bottom left. So in this example, we are considering these two tables, employee and department. So if you'll see, all the records from the table employee will be included in the result set, whereas only those records from the department table will be considered which are common in both the tables or which has a matching value in the employee table. So this is a good example to understand the left outer join. Same way, if you'll see the right join example, in the result sets, all the records from the department table will be included, but from employee table only those records will be included which has a matching value in the department table. And in the right bottom, if you'll see, this is example of a self join. We are connecting to itself. So table employee is connected to itself. And as we mentioned, it is very important to provide the table alias if we are using self join, because we cannot have the same table name in both the conditions. So I hope by looking at this example, it's more clear to you the basic concept of join. Other than that, we just have to follow the syntax and we have to take care about that which table we are placing in the on condition that is defined, that which one will be our left table or which one will be our right table. So the placement of table in the query is very important if we are looking for left and right join. If we are considering it as an inner join, then the order and placement does not make any sense, because we are going to fetch only those records which have the matching values in both the tables. So the placement of tables in the query is important if we are writing left outer join or left join or right outer join or right join. So let's move to next example, full outer join. So the full outer join keywords returns all records when there is a match in either left or right table records. If there are rows in table 1 that do not have matches in table 2, or there are rows in table T2 that do not have matches in table T1, those rows will be listed as well. It means all the rows from the left and all the rows from right will be included in the result sets, and if there is no matching values, then it will be replaced with null keyword. If you look at the syntax is almost similar. We have to just replace the inner join or left outer join with the full outer join here. So it is very easy to work with the joins. If we know the syntax of any one join, then it is very easy for us to frame the syntax for other joins also. All we have to do is that we have to replace the main keyword, what kind of join we are working with. If it is inner join, we have to mention inner join. If it is left, then we can mention either left outer join or left join. Only thing which we need to consider for this left and right join is the placement of table on conditions. So this is an example of full outer join. So I'm selecting it as a first name and department from employee as T1, full outer join department as T2, and then there's a join conditions on department number or department. So though we are getting the results from both of the table, but still we have to provide the matching condition. So if there is no matching condition, then only the null value will be included in the result sets. So it is not that since we are fetching all the rows from both the tables, so we should not provide the join condition. So let's see an example of full outer join. So we have all the records, and if there is no matching values, then we'll have the null keyword. So if you'll see, we have the 7 records here. When I execute a left outer join, we have 6 records, but here we'll be getting the result from both the tables. So there's no matching values for order ID 5 in the employee table. That's why the first row is null here. Same way, there's no matching value for employee ID 103 and 106 in the orders tables. That's why the order ID and order date is null for these columns. Again, we can omit the outer keywords from here. Instead of full outer join, we can simply say full join. So we can always omit outer keyword from all these joins, whether it is left, right, or full. So full outer join would return all the rows from the employee table and all the rows from the employee table. Whenever the join condition is not met, a null value will be included in the result set. So let's understand it with diagram for better clarity. So if you'll see here in the full join example, the entire area is colored because we are fetching all the rows from employee as well as all the rows from department, including the matching values. So if there is a matching values, that will be included in the result sets. If not, null will be included. I hope this is clear. Let's move to the next join, cross join. This is also called the Cartesian product, and it displays all rows and all columns of both the table. So what do you mean by Cartesian products? Let's understand it. So if you'll see in the upper right corner, we have the cross join example. So 1 will be multiplied with all the 3 values 1, 2, 3 from the department table. Same way, value 2 will be multiplied with all the 3 values of the department table. Same is the case with employee name 3. It will be multiplied with all. So there will be Cartesian product. That is why it is also called as Cartesian product. So some people call it cross join and some people refer it as a Cartesian product. So let's see or understand it with an example. See the number of rows. We have only 6 rows and 5 rows here. So 6 into 5, since it's a Cartesian product, so we'll be getting 30 rows. So each row will be multiplied with all the rows of another table. We have 6 rows in the employee table and 5 rows in the order table. That's why we are getting 30 rows in the result sets. So this is all about cross join. So we have discussed all joins, right from simple joins, inner join, left join, right outer join or right join and full outer join. All the examples which we have discussed, we have not included any other where clause or group by clause or having clause. So as of now we are not providing any filters. We are just fetching all the rows. Even in the inner joins we are fetching all the rows. But in practical scenario, it is not that every time we need to fetch all the records which have a matching value. So we have to provide some conditions or some filtering conditions to get the desired result sets. So let's revisit the inner join example. So we can add a condition, for example, where emp dot employee ID is greater than 104. So only those records will be included. So if you'll see, we have only one employee ID which is greater than 104 and which has a matching value in both the tables. If I'll make it 102, then I'll get two values because 103 and 106 do not have matching values in both the tables. So if I'll skip the where clause, and how I can skip? By using a single line comments. Now we have the 4 records in my result sets. By including where clause, I'm filtering the records in the result sets to 2. So we can use where clause, we can use order by clause, and on order by clause also it's not that we have to always provide the ascending, we can provide the descending keywords also. And let's see what if I'll instead of providing the column names here, what if we'll provide the asterisk or star. Let's execute this. In that case, I will be having all the columns from both the tables. When we used to provide the asterisk mark, when we fetching the results from a single table, then only the columns from that tables will be included in the result sets. Since we are creating joins or working on joins, and if we'll provide asterisk in the select statement, then all the columns from both the tables will be included in the result sets. So as per the business requirement, we include all the columns or the required columns from both the tables. Important part here is that, as we discussed earlier also, if the column is same in both the tables, then we have to have a prefix of table alias, or else we will get an error that the column is ambiguous between two tables. So far in all the examples which we have discussed or which we have executed in Management Studio, we have considered only 2 tables. But it is not that we can always join only 2 tables. If there's a business requirement, we can join 3 tables, 4 tables, and 5 tables. The syntax is same. Only thing is that we need to keep on adding the other tables and the join condition using the on keyword. For beginner level, you can start with joining 2 tables. So the important criteria for joining 2 tables is there should be at least 1 matching columns between these 2 tables. Some people says that you join when there is a foreign key primary key relationship between 2 tables. It is good to have primary key foreign key relationship between the 2 tables, but it is not mandatory that if the 2 tables are related using foreign key, then only we can apply the joins. We can very much apply the joins if there is a matching columns between both the columns, though there might not be any foreign key or even primary key. To result in a result set will be exactly similar if we are joining 2 tables having foreign key primary key and other 2 tables which do not have any such relationship. Foreign key primary key basically helps us in adding constraint. If we have some records in my child table which is referring or which is referencing the record in parent table, if we'll try to delete some record from the parent table, we'll get an error that the record has been referenced. So foreign key primary key helps us in achieving referential integrity constraints on our database, but that is not a mandatory conditions to have join in the tables. Built-in functions are used to calculate values and manipulate data. These functions can be used anywhere as expressions. When we say anywhere, It means we can use them in the select query, we can use them in where clause, we can use them in having clause. So these built-in functions can be used anywhere based upon the business requirement or based upon the type of functions which we are using. So we broadly categorize the various built-in functions into the following categories, as you can see on the screen. So we can divide the built-in functions into conversion functions, where we convert the values from one data type to another data type. We have logical functions, math functions to play around with the data, mathematical operations. We generally use math functions. Aggregate functions, if we want to calculate, for example, average, we want to calculate sum or total of salary of all the employees, then we use aggregate functions. String functions helps us to play around with various strings or characters in our data. Most of the string functions are somewhat similar to the string functions which we have in other programming language or the basic programming languages like C, C++, C Sharp or Java. Date functions have all the basic functions which we can use to manipulate date or retrieve date from our database. So let's discuss all of the functions one by one in coming slides. As we discussed that these are the various categories, again, conversion functions that support data type casting and converting. Logical functions are scalar functions that perform logical operations. These are kind of similar to the math functions are again the scalar functions which performs calculations usually based on the input values that are provided as an argument, and most of the times they returns a numeric value. Aggregate functions, as I mentioned, we use sum, we use average, we use maximum of values. So aggregate functions basically perform a calculation on a set of values and they return a single value, except for the count. So count is also an aggregate functions. Other than count, all other aggregate functions ignore null values. In the objective, we saw that we are going to discuss about the group by and having clause. So aggregate functions are frequently used with the group by clause of the select statement. Or we can say that we use group by clause only with the aggregate functions or group functions. Some people refers aggregate functions as a group functions, so don't get confused, they are one and the same thing. String functions again are scalar functions and they perform an operations on a string input value and return a strings or numerical value based upon the kind of functions which we are using. Date function, straightforward, it manipulates the dates. So let's start with the conversion functions. As the name itself suggests that these functions helps us to convert an expressions or a value from one data type to another. So we have three commonly used conversion functions: cast, convert, and parse. And in the bottom three, you can see that we have try underscore cast, we have try underscore convert, and we have try underscore parse. So the top three and bottom three, they give the same results. They work in the similar fashions. The only difference here is that the top three functions returns value of specified data type and on success throw errors on failure, whereas the bottom three, they give the null values on failure. So we can relate this try as like how we have the try catch block in other programming language to handle the exception. Same way we use try cast if you want to get the null values if something wrong happened while calculating the expressions or while fetching the results. Same is the case with try convert and try parse. But if any error happen while using cast, convert, and parse, we'll get an exceptions or we'll get an error. Whereas error can be handled by converting it to the null values if we use try, cast, try convert, and try parse. So as you can see on the slide, we are converting the value 10 as int and we are multiplying by 20. Again we are converting int 10 to int, and again we are doing a multiplication of the value after conversion with 20. So then what is the difference between cast and convert? Because the end result is almost similar. So both function can be used interchangeably in most of the situations. The only difference is that cast is ANSI SQL compliant. It follows American National Standard Institute, whereas convert does not follow any such compliance. Let's see an example of these basic operation. So I'll open Management Studio of SQL. Let's open a new query and let me copy the example. So let me copy both the examples. I increase the font size. So if I'll execute, I'm getting this result. Since we are converting 10 as int, and again, if you'll see, the result of cast function and convert functions is exactly similar. Only difference is in the syntax. The syntax of convert function is different from cast function. So one important point I just want to mention here is that in select operation, we can use mathematical operators like we can use plus, minus, divide, and multiplications. So here, after converting 10 into int, we are multiplying it with 20 to get the end result. And this is the alias which we discussed in module 2. So we can change it to any value. We can change it, let's say I'm writing it to cast result, and I can change it to convert result. Now if I'll execute it, I'll get the same results. Cast results and convert result here are alias. These are the alias for the columns. In the module 3 we saw that we use alias for the table. So let's see that if there's an issue while casting or converting a desired value, then we'll get an error when we'll use cast and convert, but we'll get a null value when we'll use try cast and try convert. Let's verify this using an example. So I'm trying to convert character into int. So we'll get an error that conversion failed when converting the varchar value a to data type int. Now let's use try cast. So I'll copy this statement. So let's assume I use try convert. And if I'll try to convert a value which is not numeric, and if I'll execute it, we'll get the incorrect syntax near the keyword try convert. Sorry, I forgot to write select. And if I'll execute it now, we'll get null value. So instead of error, we are getting a null value if we'll use try convert or try cast. So based upon the business requirement, we'll choose either the try convert or convert. Let's move to the next function. Let's discuss about the logical functions. So we have two logical functions, choose and if. Logical functions can be used to display one of the several values based on a logical conditions. So as we have discussed, we have two logical functions, choose and if. Choose returns a specified index from a list of values and returns null if the index is 0 or greater than the number of items. Or we can say that the choose basically act as an index into an array when an array is composed of the argument that follow the index argument. So as you can see in syntax, we have the choose keyword and in the parenthesis we have index. So this is the index which we have to define that what value we want to return, and this val1, value2, and we can have up to value n. So let's understand choose by an example. So let me write one example so that it will help us to understand. Choose keywords, and all these functions are basically can you see the color code? For the keywords we basically have blue colors, but for these functions we have pink color. So we'll define 3, this is the index, and then it's followed by the various values. Let's say I have test as a one value, I have just as another value, third value I'll be having rest. So if I'll execute this statement, I should get the value rest because this index does not start with 0. Please note it down. In the choose function, the index start from 1. This is one base index, not the 0 base index like we have in most programming languages. So if I'll execute this statement, I'll get rest, because we are instructing the SQL server that we want the third value out of the various values available. So choose function basically gives an error if we try to use the index as the value 0, or we'll try to provide the index which is outside this range. So let's understand it by an example. So if I provide an index 0, and if I execute this, I'll get a null value. Or if I'll provide an index which is outside the bound of this array, when I say bound, if it is more than the number of values which we are trying to select from, then again it will returns a null value. So this, since there are only 4 values here and I'm giving index 5, so since there's no value at the 5th index, it will return a null. It won't give us 0. So choose functions helps us to select from a given range of values, like how we used to fetch the values from an array. So let's discuss the other logical function. So here, before we discuss the if, let's see these examples as well. So in the first example, we are using select choose, and we are giving index 2, A, B, and C. These are the 3 values. So the first example will return the value B in the result set, because we'll count from the index 1. As I mentioned, the choose is based on 1 index and not the 0 index. So let's take the case of the second example. Here we have not provided an integer, we provide a fraction value 1.4. So choose only consider the integer value. In both the cases, it will return A as in the result set. So now let's discuss the other logical function if. So let's focus on the syntax first. So it's followed by if keyword, and then we have a Boolean expression, and then true values and false values. So when we execute this function, it returns one of the 2 values. Either it will return true value, or either it will return false value. So the output, whether it is a true or false, depend upon the evaluation of Boolean expressions which will provide in the if function. So if is a shorthand way of writing a case expression. It evaluates the Boolean expression passed as the first argument and then returns either of the 2 argument based on the results of the evaluation. So we can even provide the nesting in the if functions. The nesting should be up to 10 level, similar to the nesting which we can have in the case expression, as it is almost similar to the case expression. So let's see or discuss the example of if logical function. So in this case, it will return false because this Boolean expressions is not satisfying. 1 is not greater than 10. So it will fetch the result false in the result set. Let's execute this example in Management Studio. So you have to write if, then you have to write the Boolean expression, then any value. Let's say I'm just writing true, and the next value if it turns out to be false. Let's see the example. Yeah, the example seems to be right. Let me copy from here. Okay, so we forgot to add the select keywords. Sorry about that. And if I'll execute, it will return the false. So since there is no header for the column name, we can provide an alias as well. If I'll make this statement as true, if I'll reverse the values here, then I will get true as an output in my result set. So as I mentioned, if works like a case expression, and we can nest it, and nesting can be allowed up to 10 level. So this is all about logical functions. So let's continue with other categories of functions. So let's discuss about the math functions. So math functions can be used to calculate business and engineering calculations. So these are various self-explanatory, and we must have used these functions during our engineering classes or any other classes where we do any engineering calculation. For example, when we convert it to an absolute positive value, then we use ABS functions. If we want to generate a pseudo random float values from 0 to 1, then we use rand function. Seed is an optional value here. If we want to return an exponential value, then we use exp function. in most of the mathematical values, we need to round up the values. When the values are of decimal, then we use round functions. So round returns a numerical value rounded to a specific length or precisions that we need to provide in the functions. Floor provides or it returns the largest integer less than or equals to the specified numerical expressions. Then we have square root. Square root returns the square root of the specified float value. Ceiling is just opposite of the floor, and it returns the smallest integer greater than or equal to the specified numeric expression. Square, again, as we know, the square of 2 is 4, so like we use the square functions to calculate the square of the specified float value. Power basically returns the value of the specified expression to the specified power. So these are the standard mathematical functions. We have used these functions. So here we can see a consolidated examples of all mathematical functions. So in the first example, we see select ABS minus 10. So here we are using absolute value. So it is converting the negative values to the positive value. And all these keywords are we are using as an alias. So we are using ABS as alias for the first column. Ren, as we discussed, Ren is basically helps us to get any random values. We can provide the seed. Seed is optional when we use these functions. So as you can see, we are getting a random value here. exp4, it basically helps us to get the exponential value. Flow, we use flow, so it will get the value 4.66, will get the value 4 here. So flow, we will get the value less than the nearest integer, and the ceiling will get the values greater than the nearest integer. So if I use flow 4.66, I'm getting the value 4. When I'm using ceiling, I'm getting value 5 here. Square root, the square root of 2.56 is 1.6, so this is the value we are getting. Square is just opposite to the square root, so we'll get the square of a digit which will provide in the parenthesis. So we have provided a value 4, so we are getting 16 as its result. Power 2 3, so we are basically giving power 3. The base value here is the 2, and 3 is its exponential value. To the power 3 will get 8. It's in statesman, if you want to expand this, it's 2 into 2 into 2, so we are getting 8 as its result. Round function is basically to round the values, and we are using 2 as a precision value, so we have provided, so it is basically rounded up to 2.57. So let's execute few of the examples in Management Studio for better clarity. Let's use the square function and square root function first. So square root of 16, and always use the select statement or else we'll get an error. So I can even do like multiplications of various I can use various mathematical functions, and then I can multiply it, or I can use other operators like plus, minus. So if I'll execute this, so what I'm doing is I'm taking the square root of 16, that will be 4, taking square of 4, that is 16, so end result should be 64. Yep, so we get the result. As you can see, guys, when we don't give the name of the column, the header is blank. So it is good practice to provide the alias. As of now, I'm giving a standard keyword result set. If I'll execute it now, I'll get 64 as its value. I can even use other mathematical operator. I can use plus, so it will provide the sum of these two values. 16 plus 4, 20. So we'll get 20 in the result sets. I'm getting minus 12 its value. And let's see, can we club the functions here? So let me write select, and if I'll use abs function here, so now I should be getting plus 12 because I'm using absolute function, so it will convert the negative value into positive values. So we can club, we can nest the functions. So here in the abs functions, I'm using sqrt functions and square functions. We can play around with these functions as per our business requirement. Let's use an example of power. Let's use the base value as 2, and it's 2 to power 4, so the result will be 16. So this is equivalent to, sorry, if I'll expand this power, 2 is the base and 4 is the exponential. So I'll get the same results at 16. So this is all about the maths functions. Let's move to another category. Ignores null values. Aggregate functions are frequently used with a group by clause and for filtering, like we used to filter the data using where clause. So if you're using group by clause, then we use having keyword to filter the result set. So we have following aggregate functions. We have average, min, sum, count, and max. So let's start with average function first. So average returns the average of the values in a group. As we discussed, null values are ignored. So let's take an example of average function. First, let me fetch the values from department table. Okay, so I can use the average functions on department number column. So I can write select average. I'll write the column number from department. If I'll execute this, I'll get the average of the values. So let me execute both the queries in Funko so we can compare the results. So 25 is the average of 40 plus 30 plus 20, 10 divided by 4. So we can use average functions with a distinct keyword. We discuss about the distinct keyword in module 2. So distinct keyword helps us to fetch the unique records. So if you want to find the average of the distinct values, then we'll provide the distinct keyword before the column name. So let's take another example of the average function. Let me get the results from employee table. So as we discussed that average functions ignores the null values. So if I'll try to get the average of salaries, so we have only 3 rows where the salary is present, rest all the values are null. Let's see what is the result. Select average. I'll provide the name of the column from employee. So this is the average. So let me execute both the statement in Funko like I did earlier. So you're getting the average of this. So we can use average with the distinct keywords if you want to fetch the results. Okay, let's see whether we can apply the distinct here. So in the department 1 table, we have the repeated values for the department number. So if I want to ignore the repeated or redundant data or the duplicate data, then I can use the distinct keyword. So if I execute it now, I'll get the average as 25. But if I'll remove the distinct keyword, the result sets will be different. Sorry, my bad. I'm using department column. I have to change it to department 1. So let's first see the result set without using the distinct keyword. The results is 30. Now I'll use the keyword distinct. So the value is different because I'm just taking the unique values for my result set. So let's move to another aggregate function. Let's discuss the min function. Similar to average, min also ignores the null value and it returns the minimum value in the expression. So if I'll see the values in the department 1 table and if I'll try to find the lowest value of the department number, then I have to use the min function. Okay, so out of all the aggregate functions, count is the only one which takes into account the null values as well. So let's see the example of count. Let's move to Management Studio. So I'll be using employee table because we have a lot of null values in those. I'll execute this. So let's take the count of the salary column. Select count. I have to write the column name, employee. So if I'll execute, I'll get 3 results. But if I'll execute star, I'll get 9 columns. So even we can use the distinct operation here in the count function. So count basically fetch the count of rows from a table. So let's move to another aggregate function. We have max. So max is exactly opposite of min. We have already shown example of minimum. So max, we can use it for numeric as well as with the character data type. If we use for the character data type, it will show the maximum value in the sorting order. If we use with the numeric, then of course it will show the maximum of the value. Though let's see an example of max as well. So if I'll use max, we're trying to find the maximum salary from employee table. So this is the maximum salary. And if I'll try to find the location, let me first show you the various location from the department table. So as per the sorting order, we should get Hyderabad if we'll use max for this column. So let me write the query, select max LOC from department table, and we can provide an alias as location. So I'll get Hyderabad in my result set. So we have discussed all aggregate functions. So the common aggregate functions are average. If you get the average of values, min, as the name suggests, the minimum value in the expression. Sum helps us in finding of the total for a column. Sum only accepts the numeric value. Count returns the number of items or rows in a group or in a table. Max returns the maximum value in the expression. So let's move to other category of functions. So these are the various examples. Before we move to other functions, let's see the examples here. So in one example, they've shown all the aggregate functions. So we can use multiple aggregate functions in the single statement, a single select statement. So in the single select statement, we have used average of salary, minimum of salary, maximum of salary, and the sum of salary from employee table. Second example is for the count functions. So we will discuss about the group functions and heavy functions once we are done with most of the out-of-box functions. Then we have string functions. String functions are again scalar functions, and they perform an operations on a string input value, and they return a string or numeric value based upon the type of functions which we are using. When string functions are passed arguments that are not string values, the input type is implicitly converted to a text data type. So these are the various string functions. Ltrim, it basically returns a character expressions after it removes leading blanks. It basically removes the blanks from the left hand side of the string. We have rtrim, it returns the character string after truncating all the trailing blanks. Basically it removes the blank from the right hand side of a string. Char functions converts an int ASCII code to a character. Character index find out and searches and expressions for another expressions and returns its starting positions if found. str returns character data converted from numeric data. Concat return a string that is results of concatenating 2 or more string values. So these functions are almost similar to other string functions which we use in other programming languages. So in most of the programming languages, we have trim functions, we have functions to find out the index of a character. We use concatenate operation. This is a very common string functions to concatenate 2 strings or more than 2 strings. Then we have replace functions. So replace all occurrence of a specified string value with another specific value. We have substring, it returns part of a character or text. based upon the length or the start index which we give in. As we can see in the syntax of the substring, we have a substring keyword followed by the expression, like the string from which we want to find out the part of a character. We'll define the start index, and then we'll define the length, that from start index till how many characters we want to fetch the substring. Then we have the format functions. We can format strings into desired format using the culture. Then we have left functions. It returns the left part of a character string. The opposite of left is the right functions, which returns the right part of a character string. Reverse return the reverse order of a string value. Upper functions converts the string into uppercase, opposite of which is the lower functions, which converts the expressions into lowercase. And in the end, we have length function or len, which basically returns the number of characters of the specified string and exclude the trailing blanks. So these are the various examples on our slide. So first one is for the replace function. So this is our string, and this is string we are replacing CDE with XXX as the replace. So as you can see in the result set here for the replace column, the value CDE is replaced with XXX. We have substring functions. In the substring, we are get out of this ABCDEF, which is our main string, from index 2 and till length 3, we are getting the substring. So index 2 is start from B, and then up to 3 character we'll get the substring. So we'll get B, C, and D in our output. Then we have left. So it basically return the left from a character index. So from index 2 we are getting the values from the left. So it is A and B. From the right we are getting the value of B, C, D. So in the end, we have the examples of date and time and format. So here we have provided the various culture values. So first is for US English, second is for British English, and third is for the German. So based upon the info culture, we basically get the different results here. So most of the string functions are pretty much straightforward. So let's discuss about a few of them. So we'll discuss about a reverse. So I'm adding a string A, B, C. Again, I forgot to add the select statement. This will give me an error if I'll try to execute this statement without select. And if I'll execute it now, I'll get the reverse of the string. Always good to provide the alias. Then we have trim or ltrim. Select ltrim. So I have added leading blank spaces in this string, and if I'll execute this, the leading spaces has been trimmed. Same way I can use rtrim. So if I'll use rtrim, then only the trailing spaces will be removed, not the leading one. If I'll execute this, I'll get this result. And if I'll use trim, then it will consider for both. So we do not have trim here. So ltrim removes the leading spaces and rtrim removes the trailing spaces. So this is all about the string functions. You can practice about the other string functions. They are pretty much straightforward. Let's see an example for the upper and lower functions as well. So if I use lower here, I'll get the same result. But if I'll use, or let me convert, let me first write the uppercase character. So it's convert into lowercase. And if I'll write the lowercase, and if I'll use the upper function, it convert it into uppercase. So all other string functions are also self-explanatory. Please try all of them so that you will have an idea. And if you try all of these, you will come to know that if the situations arise, you can start using those. So let's move to other functions, the date and time functions. So date and time functions are again scalar functions that performs an operations on a date and time input value and returns either a string, numeric, or date and time value. So as you can see on the screen, there are various date and time functions again. we have sys date time. It returns a date time value that contains the date and time, its current timestamp. Against return a date time value that contains the date and time. Date part basically fetch as the date part of a date component. Day, month, year returns an integer that represents the day, month and year part of the specific date. Date if returns the number of date or time date part boundaries that are crossed between two specific dates. And dateAdd functions returns a new date time values by adding an interval to the specific date part. So let's see the examples of date and time functions. Sys date time, it returns the system date time, so it has date component as well as the time component. Current timestamp also gives the current date and time. Date part basically provides, if you'll provide year here, then it is providing the year of the date part. If I'll provide here the dd, it will provide the day. If I'll provide it will provide or fetch the value of the month. Date difference, so again, if we are providing so we are getting the difference of month between these two dates. If I'll provide dd, then it will provide me the difference of days between the two dates. So dateAdd is that I am adding 2 months. So this is how we have to do. Since we have provided specify for month here. If I'll provide the dd, then it will add 2 days. Since we have provided here, so it will add 2 months to the current date. So let's see one example here. Date part, year. Now let's say and then we can provide the date. Is providing the month. So 12th month, since I'm using December. If I'll change it to October, and if I'll execute it again, it will show me that value 10. So this is how we use the date part. And let's see the dateAdd function. So if I execute it now, it will add 2 months. I can also provide dd here. So it will add 2 days. So this is all about the date functions. So now let's discuss about the group by clause and having clause. So as you can see, we are using group by keyword here, and we are using having keyword here. So let's discuss about the group by and having clause. Let's discuss group by first. The SQL group by clause is used along with the group functions to retrieve data grouped according to one or more columns. The important part here is that the group by clause should contain all the columns in the select list except those used along with the group functions. So let's see an example of group by functions for better understanding. Let's move to Management Studio, and we will use department 1 table for group by clause. Let me first execute this query. So what I'm going to do, I'm going to group by the department number. So I'll find select count of rows from department 1. Then I'll use group by keyword, and I want to group the data by department number. So can you see? It's grouped. Or even I can write the department number. And let me write the alias for this. And I'm writing the alias here as department number. If I'll execute this, I'll get, so we have count 4 for the department number. There are 4 values for the department number 20, same way 5 values for department number 30, 5 values for 40, 1 values for department number 50, and 1 value for department number 80. So we use group by functions generally in association with aggregate functions. So it helps us in grouping the data in a table. The important part here is that we have to use all the columns in the group by which are there in the select statement. So if I'll try to include location here. There's one more column, locations, in the department one table. But if I try to execute it now, I'll get an error because all the columns other than the aggregate functions should be there in the group by clause. So if I'll include the other table as well, then the query will be executed successfully. So in order to execute group by successfully, we have to include all the columns which we are including in the select statement in the group by clause. And also we can include multiple columns in the group by clause. It is not that we have to use only the single column. So group by helps us to group the data in a single table, and it is generally used along with other aggregate functions. So let's see the example. So here we are basically again grouping by the department number here. So let me fetch the results from the employee table. So here we can group the records again using the department number or using the job ID. So if I were to use for the employee table, I'll write select job ID, job underscore ID, and then again I can use, for example, let's say count. It's not that we have to always use the count aggregate function. We can use other aggregate functions also from employee, and then I'll write group by job ID. So this will group the data according to the job. So only for a job ID 7 we have 2 rows. For all other job IDs we have a single row. So we are clear with the group by. Now let's discuss the having keyword. So the having clause was added to SQL because the where keyword could not be used with the aggregate function. We cannot use a where keyword with this aggregate function. So having applies to the summarized group records, whereas where applies to the individual records. So if it is a summarized record or the group, when we use group by, then we have to use having, and if it is the individual records, then we'll use the where clause. So if we'll use the having clause, only the groups that meets the having criteria will be returned in the result sets. And having keyword requires that we'll use group by in our SQL query. So we can say that the having clause is used in combination with the group by clause to restrict the group of return rows to only those which is matching the conditions or where the conditions is true. So let's see an example. So here in this example, we are selecting the department number, taking the average salary, minimum salary, and the maximum salary. And we are finding that if the sum of the salary is greater than 3,000, fetches only those results. So let's see this example in the Management Studio. And I can write here, having salary greater than, let's say, 30,000. Oh, we have to include the minimum salary. We have to use the aggregate functions in the having clause. Yeah, so we get only 2 results. So let me first show you the result sets. So we have 3 rows which are having the value for the salary column. J4 having salary of 40,000, J5 is blank, so we have J6 as 500,000, and then we have J1 as 30k. So as per our query, we should get only the 2 results, that is J4 and J6, because these are the only 2 rows which are satisfying the having clause. So having is kind of we used to filter the result sets, but with the aggregate functions we cannot use where command, so we are supposed to use having clause. So this is it about the various out-of-box SQL functions. And first we'll discuss about the store procedure. A store procedure is a set of SQL statements with a name, that has been created and stored in the database. So when we execute or when we write SQL statement, but we are not storing those queries. But in store procedure, we can write a set of SQL statements and we can, execute them and they can store in the server. So every time I don't have to write SQL queries, I can write my business logic in the store procedure. So stored procedures can be defined as a set of logical group of SQL statements which are grouped to perform a specific task. So basically in stored procedure, we write most of our business logic. So like other programming languages, stored procedures accepts input parameters. They return multiple values by means of out parameters or output parameters. They contain programming statements. A stored procedure can call other stored procedures or functions. A return status to indicate success or failure. Let's see the syntax of stored procedure first. So this is the syntax. We have create keyword to create a stored procedure. We have to write create followed by a keyword procedure, name of the stored procedure which we want to create. If you want to provide any parameter in the stored procedure, then we'll provide the parameter name. If we want to create the parameter as an output parameter, then we have to use the keyword out or output followed by as keyword, and we'll write begin, and whatever the statement or competitions we want, we'll write that, and in the end we have to write end keyword. So in the syntax it is mentioned that it is create or alter. So if we want to modify the existing stored procedure, then we have to use the keyword alter. If we are creating the stored procedure first time, then we have to use the keyword create. So alter keyword is used if you want to modify any existing stored procedure. Now, why we create stored procedure when we can write SQL queries? So here are some of the benefits of creating stored procedure. All commands in a stored procedure are executed as a single batch of code. When we execute queries in SQL, generally each query goes as a single batch. But when we execute stored procedure, though it may have multiple SQL statements, all SQL statements are executed as a single batch of code. So by doing this, it reduces the server or client network traffic and improves the performance. Stored procedures helps us in achieving strong security in SQL because we can impersonate another user. Execute as can be specified to enable impersonating another user to perform certain database tasks without providing direct permissions to the processor. So it makes our environment more secure. Reuse of code. Stored procedures helps us in achieving reusability because as we discussed in the previous slides, that we can call another functions or stored procedures from one stored procedure. Easier maintenance. Changes need to be done within the stored procedure which handles all DB operations, and no changes are required in client applications. So sometimes we move our business logic to the stored procedure. So if any changes are required, we need to modify our business logic, then we don't have to change our client applications or our code. We have to just modify the stored procedures and execute it again. Also, if there is any error, we know where exactly to look for, and we have to debug only one stored procedure instead of looking for multiple SQL statements. That is the reason stored procedures are easier to maintain. Improved performance. All procedures by default are compiled in the database the first time it is executed, and it maintains the execution plan for subsequent call. So if we'll execute or if we'll call or run the stored procedure again, it will take less time because it is already compiled in the database the very first time. So by doing this, the performance of applications has increased. So on this slide, we can see an example of stored procedure. So we are creating a stored procedure. So we are writing first the create keyword followed by the procedure. sp_get employee info is the name of the stored procedure. This stored procedure, we are passing a parameter employee ID whose data type is int. Followed by the basic syntax, we are defining the keyword as and begin. And then we are writing the basic query that select employee ID, first name, last name, manager ID, phone number, hire date, job ID. These are the columns of table employee. And then we are passing the condition, we are filtering the records from employee table by using a where clause. And in the where clause, we are not hard coding any value. We are equating it with an employee ID, which is the parameter. So when we will execute this stored procedure, we will pass the parameter. So let's see a few examples of the stored procedure. So let me open Management Studio. So let me open the examples I've already have. So let's create a stored procedure without parameter first. It is not that every time when we'll create a stored procedure, we have to define a parameter. So I'm writing a create keyword followed by the procedure, and all result keyword will be highlighted in the blue color. Then I'm providing a name of the stored procedure. So I can provide any name here. So I'm providing a get details, or I can mention it to give it more meaning, get department details. And the stored procedure, I have simply written a one select query that selects star from department, and I'll execute this query. Command completed successfully means we have successfully created the stored procedure in database. Now where to check for the stored procedure? So I'll first expand the database under which I'm creating the stored procedure. An important thing, guys, is that we have to use the database first, that under which database we want to create our stored procedure. So always write the name of the database, use keyword followed by a go keyword. Now if we'll try to execute this statement again, I'll get an error that this is already an object name USP get department details in the database. So since I've already created this stored procedure, if I'll try to create it again, it will give an error. So when you provide a name of the stored procedure, please ensure or please check that the name which you are providing is unique and it does not exist in the database in which you are creating that stored procedure. So if I want to check where exactly the stored procedure has been created, I have to expand the programmability folder. Under programmability folder, we have a separate folder for the stored procedures. Let me refresh it. So here we can see the stored procedure, DBO USP get department details. So from this object explorer, I can modify the stored procedure, I can execute the stored procedure, or even I can delete it. So to delete it, we have to simply click delete here. It will again reconfirm whether we actually want to delete this stored procedure, and if there are any dependency of this stored procedure, we can check it with the show dependency. So when we delete something from our database, it is better to check the dependency. If there are any dependency, we rather not delete that particular object. So as of now, we know that there's no dependency, so I'm just clicking OK here, and it will delete the stored procedure. Since we have deleted the stored procedure, and now if I'll execute this statement again, it will be executed successfully as there was no stored procedure in our database, and by execution of the statement we'll again create that stored procedure. So if I'll refresh this stored procedure again, I'll see the stored procedure. Now we have created the stored procedure, and we'll see how we can execute this stored procedure. To execute this stored procedure, we have to write one command. So there are various keywords which we can use to run this stored procedure. The first one is we have to write this keyword exec followed by the name of the stored procedure. So if I'll execute this, it will execute the stored procedure and it will return this query or this result set, because in the stored procedure we have given only one select statement that selects star from department, and the department table has 3 columns. So we are getting all the rows because we have not specified any where condition. So this is an example of a stored procedure without a parameter. Since the stored procedure doesn't have any parameter, we are not passing any parameter while executing this stored procedure. So it is not mandatory to provide the exec keyword while executing the stored procedure. Even if you'll provide the name of the stored procedure and if you'll execute it, it will fetch the same results. So exec keyword or execute keyword is optional while executing the stored procedure. So let me again delete this stored procedure So while creating the store procedure again, we can either provide the create procedure, or we can even provide the short form that create proc. Even if I'll execute the statement, it will be executed successfully. And if I'll refresh this node, we can see the store procedure has been created successfully. While executing, again, it is optional to provide the execute keyword. Similarly, while creating the store procedure, we can either provide create proc or create processor. Now let's see how we can create a store procedure with a parameter. So I'm opening a new query window. I increase the font size for better visibility. So this is an example of a store procedure with a parameter. So here we are providing the parameter department number. So here we have department number as a parameter, and the data type of this parameter is n_var_char and length is 30. So in the previous example, we have written a select statement but without the where clause. Here I'm providing, or I'm filtering the record or rows by using where clause, and the where clause I'm checking the depart number with the parameter which will pass while executing the store procedure. So let me create the store procedure first and then we will execute it. The command completed successfully means the store procedure has been created successfully. So let's again refresh this node. Yeah. So now when we are executing this store procedure, even like as we saw that we can provide the execute keyword, or we can even directly write the name of the store procedure, or if we are using the management studio, we can right click the store procedure and then we can click execute store procedure. So the execute store procedure will open this window, and if there are any parameter, it will check whether what value we want to pass to this particular parameter. As we know that we have various values of department number start from 10 to 80. So I'm passing 20 as a value for the department number, and I will click OK. The moment I'll click OK, I'll get this result. So in earlier example, we got all the rows in the result set. So if we do not want to execute this store procedure from the object explorer, then again we have to write the same command. We have to execute keywords followed by the name of the store procedure, and then we'll pass the parameter. In our case, the parameter is department number. So now this will give the desired result. So this is how we create store procedure with parameter, and this is how we execute the store procedure which has a parameter in it. Now if we'll try to execute this store procedure without providing the parameter, now let's see what happens. See, you will receive an error. The procedure or function USB get detail expect parameters which was not supplied. It means when we created the store procedure, we have ensured that the parameter which we are providing in our store procedure is mandatory. Why? Because we have not explicitly defined that this parameter can accept null value as well. So if you want to make the parameter null, then we have to explicitly provide the null keyword. So let me modify this store procedure, or let me first delete this store procedure and we'll recreate it again. So I'm just deleting the store procedure. And in order to make our parameter optional instead of mandatory, we have to provide the keyword null. And I'll execute the statement again to create the store procedure. Now if I'll execute this store procedure, we won't receive an error, but we won't get the value because we are checking the null value, and if I not provide any null, so it will not return any result. But yes, the error is gone. So this is how we make the parameter optional by providing the null keyword. Now let's see how we can create a store procedure with multiple parameters. Or is it possible to create a store procedure with multiple parameters? Yes, it is very much possible to create a store procedure which accepts multiple parameters. So let's see it with an example. Let me open a new query again. And we already have an example handy with us. Let me paste it in Management Studio. So we have this stored procedure, and here in the stored procedure we have defined two parameters. One is department number and department name. We have make both of these parameters as optional by providing the null keyword. So if you want to create or we want to define multiple parameters in the stored procedure, all we have to do is that we have to separate the two parameters with a comma. That's it. Rest everything is same. We have to provide an as keyword after the parameters, and then we'll write the stored procedure body. In here we are again writing a select statement, but we are adding a where clause to filter the result sets by providing two conditions, and we are using logical operator, that is AND, to combine two conditions. So let me execute these statements to create a new stored procedure with multiple parameters. The stored procedure has been created successfully. We'll refresh this node, and this is the stored procedure. So let me first see the data in our table so that we can provide the right parameters values to get the values in the result set. Okay, so I'll pass the parameter department number as 50 and department name as IT. So all I have to do is I have to provide the keyword execute, name of the stored procedure, get details from, then we have to provide the value for first parameter, that is department number, its value. So we have decided to pass its value as a 50, and then we'll provide the value for another parameter. Since it is string, we have to include it is in single quotation, and now I'll execute this and we'll get the desired result that department name is IT and is located in Mumbai. So this is how we'll execute and the stored procedure with multiple parameters. So we write the name of the stored procedure and followed by the first parameter, then write a comma and then the second parameter, and so on. Parameters also in other stored procedure. If you want to execute it from the Object Explorer, then you have to right click the stored procedure and we'll click execute stored procedure. We'll get both the names, we'll pass the value here and we'll click OK. If I'll click it OK now, though there won't be any result in the result set, but it won't throw any error because while creating the stored procedure, we have defined that these two parameters can accept null value. So they are not mandatory, these are optional. That is the reason, even though we won't provide any value, we won't receive one while executing the stored procedure. Now let's discuss about the output parameter in the stored procedure. So if we want to return the value of the parameter, then we have to define an extra keyword, that is out or output. Both keywords are valid whether we use out or output against the name of the parameter whose value we want to return. So let's see it with an example. So I'll open a new query. In the stored procedure, I have two parameters. One is the department number and one is count. So we have defined a keyword output which suggests that this parameter will be the output parameter. So we can pass the value to this parameter, and this parameter will also return the value after execution. So we can provide the keyword output or out. There's no difference. The end result will be the same. Stored is created. We'll refresh the node of the stored procedure to see the results. Yep, we have the stored procedure. Now in order to execute this, we have to do like this. We have to first declare the count int, followed by the executive name of the stored procedure. Will provide the value. This is how we have to define if it is an output parameter, and then we are writing the select statement to see the value of the count. So let me execute this. So the count is 1 because there's only one row with the department number 10. So this is how we use the output or out keyword against the parameter. Now let's see how we can add comments in the stored process. So we can add the comments in two ways. One is the line comment and one is block comments. So if we need to provide the line comments, then we have to use 2 dash followed by a statement. And in order to / and then star, I'm just writing this is multi-parameter stored processor having output parameter. Again, we'll write star and a /. So this is how we define the comments in a stored processor. Not only in the stored processor, we can write or define the comments anywhere in SQL queries, whether it is a functions or normal SQL statements or it is a stored processor. So line comments or single line, we use 2-, and for block comments, we use / and star. So let's see how we can handle the exception in the stored processors. So if you have handled the exceptions in your programming languages like C, C++, or like Java or C#, then we use try catch there. And along with try catch, sometimes we use finally block, because finally always execute. So if you want to close some, like we want to close some connections, or we want that some statement to execute no matter whether there's exception or not, then we write those statements in the final block. So we do not have any final block in the stored processor or SQL. We have, let's see how we can define the try and catch blocks in stored processor with an example. Let me first increase the font size. I'm creating this stored processor with the name DBO USP try catch test. And to write a catch block, we have to provide the syntax begin try. Then in the body, we'll write whatever the statement we want to write, and then followed by the end try. So end try basically ends the try block. After that, we'll provide begin catch, and in the catch, see what we are doing here is that we have written a select statement that we are providing what is the error number, what is the severity of this error, what is the state, procedure, in which line the error is encountered, and the error message. So let's create the stored processor first, and then we'll refresh this node. So we have this stored processor, and now this stored processor do not have any parameter. So I'll execute the stored processor, execute keyword followed by the name of the stored processor. No parameters, so we are not passing any parameters while executing it. And see, since we are dividing by 0, it will give an error. It will result in infinity. And see, since it will go to the catch block, since error has encountered, so we have written the statement in the try block. So in the catch, we are handling the exception, and while handling the exception, we have written a select statement which provide all these values. So the error number is at 134, error severity is 16. So these are the predefined severity levels. So we can check on Google said what the severity, error severity 16 means. Then we have error state, in which processor the error has occurred. So it will give you the name of the processor. The name of the processor is USP try catch test. Error line is 4, and the error message that we are dividing by 0. So we'll get the message that divide by 0 error encountered. So this is how we mentioned try catch block in the stored processor. We have seen various examples of the stored processor. So we have created the stored processor without parameter, with parameter. We have created a stored processor with multiple parameters. We have seen that how we can include comments in the stored processor using single line comments or block comments. And we have seen that how we can handle the exception in the stored processor. So this exception handling is not only for the stored processor, we can handle these exceptions in functions as well. So we can write try block and followed by a catch block. In the catch block, again, we can write the select statement to show the message that where exactly what is the severity level, what is the error message. We can even provide the custom error message. It's up to us. So let's move to the next topic. So I hope you are clear with the concept of stored processor in SQL. Let's move to the next topic. The next topic is user-defined functions. So though SQL Server provides list of many predefined functions that are built into the TSQL language, these supplied or out-of-box functions helps in extending the capabilities of SQL by providing the ability to perform like string manipulations, mathematical calculations, data type conversions by using converter cast functions, etc. But sometimes these out-of-box functions or inbuilt functions are not enough, and there are certain functionalities which is not provided by these functions. So this issue can be easily addressed if we can create some user-defined function. So like functions in programming language, in all programming language we write functions. There are some functions which do not return any values. There are functions which returns a value, and we pass parameters. We do not pass parameters while calling the functions. So user-defined functions in SQL are almost on the same lines of the functions in other programming languages. So user-defined functions are compact piece of transact SQL code which can accept parameters, like how we pass the parameters in stored process. Same way, functions can also accept parameters. Functions can perform complex calculations and return either a value or a table. So this return type is basically based upon what kind of functions we are creating or executing. So let's discuss what are the various benefits of user-defined functions. So again, like stored processor, functions also helps us in achieving the concept of reusability. It will prevent us from writing same logic multiple times. We can dump a set of SQL statement in a function and we can call it as many as times. Like stored processor, they also improved the performance because the user-defined function reduced the compilation time of SQL query by caching the execution plan and reusing it. Functions are also easier to maintain because functions help us to separate the complex calculations or the complex business logic from the regular SQL query so that we can understand and debug the query quicker and better. It again reduces the network traffic because of its caching plan. Functions again can be used in where clause as well. By this, we can limit the number of rows sent to the client. So we can use functions in select clause and we can use the functions in where clause. Now let's discuss about the structure of the functions. User-defined functions are composed of two parts. One is header and one is function body. We'll see in some examples that how we create functions. So the header contains the function name, input parameters, if there are any input parameters, because again, the parameters are optional, whether it's a stored processor or whether it is a user-defined function. Along with parameter, we have written parameter info, its name and type in the header section. The function body contains the logic, any business logic. So it contains one or many SQL statement depending upon what we are writing in the function body. As you can see on the screen, there are, if you need to divide the user-defined functions in some broad category, then we can divide into two broad categories. One is the scalar value functions and one is the table valued function. The table value function can again be divided into inline table value functions and multi-statement table valued functions. Let's move to the next slide. Let's first discuss about what are the scalar functions in SQL. Scalar functions returns a single data value of the type defined in the return clause. If it is an inline scalar function, we even don't need a function body. We use scalar functions when multi statements need to be provided within beginner and block. So let's discuss about the syntax. As I mentioned that the syntax contains header and body. So the create alter function, which is basically the header of the functions. In the header, we can define the parameters, the return type parameters, and then in the begin and end, we define the function body. What are the SQL statement or any computations or any calculation which we are doing, we basically do it in the body of the function. So if we need to summarize, the scalar functions are functions which returns a single value. They return scalar values or single values that can be used anywhere a constant expression can be used. And every function, whether it is a scalar or whether it is like table value functions, every function must return a result using the return statement. This is kind of mandatory. So let's see some examples of the scalar functions. So in this example, we are creating a function with the name fn underscore get department number. So we are creating a parameter employee ID of the data type int here. This functions basically returns a int data type. Then there's a begin keyword. After begin keyword, we are defining the body. In the body, we are writing select department number from employee, where employee ID is employee ID, where @employee ID is the parameter which will pass when we'll execute this function or will run this function. So in the right hand side, we are executing these functions, and we are executing these functions in the where clause. Just pay attention. So in the where clause, we are mentioning where department number equals to, and then we are calling the function by providing the parameter. So when this function will execute, it will be replaced by the value which the function will return. And then that value will be used in the where clause to filter the data. So let's discuss some examples of functions for better clarity. Let me open Management Studio. Let me close these queries first. So we'll first create a function, a scalar function without any parameters. So this is the name of the function, no parameters. We are not creating any parameters here. The return type is int, and I'm just returning in the return statement. We have just provided a SQL statement that selects some salary from employee. After executing this, function will be created. This is a scalar function. So if you want to verify whether the function has been created successfully, then we have to refresh our database. So we have created this function in EmployeeDB database. I'll refresh that, and I'll expand the programmability. In programmability node, we have subnode called functions. Again, in functions, we have 4 nodes: table value functions, scalar value functions, aggregate functions, and system functions. If I'll expand the scalar value functions, we can see the name of the functions here. So in order to execute this function, we have to write select statement followed by the name of the function. If I'll execute, we have provided the parenthesis. So this function will return the sum of the salary from employee table. So let me show you the data which is there in the employee table, so that we can verify our result, whether I got the right result or not. So if we'll calculate this, we'll get 570K. This is the sum of the salary for all the employees, since we have salary for the 3 employees only. So this is how we'll create the functions without any parameter. Let's see how we can create a functions with parameter. So in this function, we are providing 2 parameters, first name, and the data type of the parameter is varchar50. The second parameter is the last name, and the data type of second parameter is again varchar with the same length as of the first parameter. Return type is also of the same data type, and then in the body we are executing the SQL statement. So what we are doing, we are just concatenating. So if it is a mathematical operations, if we provide the plus operator, then it will add the 2 values, but if it is string or varchar, then it will concatenate the string. Space is a function it is an inbuilt function in SQL which basically add a space, empty space. So what we are doing, we are concatenating first name and last name, and we are adding a space between the 2 names to make it more readable. So as you can see, when I hovering over the space keyword, it is giving me a message that this is a built-in function. So let me create this function first. Function has been created. Again, this is a scalar function, but with parameters. Let me refresh the scalar valued function node, and I can see the function name. Let me execute this function, name of the function, and then we have to pass the parameters. So I pass 2 parameters here, comma, and the name of the second parameter. Why I'm enclosing it in single quote? Because this is a string type, and if you want to add an alias for the column name, we can mention it as full name. So if I'll execute it again, we'll get the result Joe root here. So this is how we'll create functions with multiple parameters. and we can call the functions in the select statement, or we can we call in the select statement, right? And we can even call the functions in where clause, as we saw in the example in the PPT. Again, in the previous example, let me first increase the font size. We can even use the functions in the where clause. So how we can use it? Let's assume I'm calling this query select star from employee, and let me first alter this function. So to alter this function, we have to use the alter keyword, and instead of sum, I'm just finding the average salary of the employee, and I'm executing again. So this is how we modify the function, existing function. Same way we can modify the stored procedure also. So alter is the keyword which helps us to modifying the existing functions as well as existing stored procedure. If I have to use the functions in the where clause, so this is how we'll do. Let me show you. So I'm writing a query. So what I want to do is that I want to select the employees whose salary is greater than the average salary. So I'll write where clause where salary is greater than, then I'll call the function. So if I execute it now, I'll get only one result because there's only one record of one employee whose salary is greater than the average salary of all the employees. So this is how we can include, or we can call the function in where clause as well as in the select statement as per our business requirement. So let's move to the next topic. So we are clear with the scalar functions, I believe. So let's move to the next type of function, that is the table valued functions. And as I mentioned earlier, we have two types of table valued function. One is inline, one is multi-valued. So inline table value functions are a subset of user defined function that returns a table. So scalar functions returns only a single value, whereas the inline table value functions returns the entire table. So inline functions, if you remember, we have created view in a first module. So we can use inline functions if you want to achieve the functionality of parameterized view. Inline table value function can also be used to support parameters in search condition specified in the where clause. So these are some of the rules which are common for the inline table valued functions. The return clause contains only the keyword table. Format need not to be defined for the return value. There is no function body delimited by begin and end. The return clause contains a single select statement in parentheses, and the table valued function accepts only constants or the local variable arguments. This is the syntax for the inline table value functions, as you can see in the slide. So the return type is table here, and we generally have the SQL statement. So this is an example. In the last slide we saw the syntax. This is the example. So here in this example we are creating a function get employee info. We are passing the parameter employee ID, and it is returning the values as a table, not as a single value. And the return statement, we are providing the select statement where we are returning the values of employee table, and we are filtering the result cells by using the parameter employee ID. And this is how we'll execute. So if you remember, when we executed the scalar value function, we did not use select star from, we simply mentioned select and the name of the function. But if we are using table value function, then we are using the select star from, because we are kind of, as you mentioned, we kind of use it for parameterized view. So if you need to fetch the values from views, then again we use select star from the name of the view. So let's see an example of inline table value function. Let me open Management Studio. So this is example of inline functions with no parameter. We can create parameter in the same way we created the parameter or we define the parameters for the scalar value functions. So I'm creating a function top 10 customers. We are returning a table, and in the return statement I'm just writing a select statement, select top 10 from employee. Let me execute this to create this function. Now I'll execute this function. So to execute this, I have to mention the select clause select star from and then the name of the function. So I'm getting, so there are only 9 rows, so it's just fetching the 9 only. So if I can go ahead and modify it, instead of top 10, let me modify it to top 5. So to modify the function, we have to use the alter keyword. So we got the top 5 results. This is how we create the inline table valued function. So this is an example of the functions without any parameters. If required, we can go ahead and create the parameter as well. So to create the parameter, we have to define the parameter name here, and then we have to provide the name of, data type of a parameter, and then we can write a where clause. Now let's say where employee ID is greater than employee ID. Command executed successfully, and now if I to run this, I'll pass a value to the function. If I'll execute, it will get the values in the result set whose employee ID is greater than 1003. I hope this is clear, and let's move to the next topic. So we'll discuss the next category of table valued function, that is the multi-statement. So in the inline function, we can use a single statement. But in multi-statement table valued function, we can use multiple statements. So again, they also return a table data type. So the return clause defines the format of the table. We cannot provide the format in the inline table valued function, but yes, we can provide the format of the table in multi-statement table valued function. The transact SQL statement in the function body build and insert rows into the return variable defined by the return clause. And the rows inserted into the variable are returned as the tabular output of the function. So here we have the syntax for this. To modify, we use alter keywords. To create, we use create keywords, name of the function. If you wish, we can define the parameters which you can consume in the function body. Return type will always be the table, but here we can define the format which is not available in the inline table valued function. Let's see an example. So this is an example here. So we are defining the format of the table, and we are defining that the table will be the retired get employee info, and we are providing 4 columns here, and we are defining the data type, we are defining the constant on the table, we are defining whether there's a null constant or not on those columns. And in the function body, we are inserting records in the table, and we'll fetching from the employee, and we are filtering the result set by using the parameter which will pass when we'll execute the function. So let's see one more example other than this. So you can use the same example and execute it. We'll try to write the entire thing, then it will take time. So I'm skipping the example in Management Studio. But the basic difference between these two functions, table valued function, is that here we can format the table and we can use multiple statement in the function body, which is not the options in the inline functions. So we already discussed the benefits of user-defined functions, modular programming. It saves time because we can write or dump the statements in a function and use it or call it as many as number of times. It's faster executions because of this. It caches the execution plan and use it for the subsequent calls, and it reduces the network traffic. So these are few of the main benefits of user-defined functions. So we have discussed the user-defined functions, and I hope you are clear. So we can extend the capability by writing user-defined functions, and we can achieve the functionality which cannot be fulfilled by out-of-box or the inbuilt functions of SQL. Now we'll understand what triggers are. As the name suggests, it's some database object which triggers automatically. Or we can say that trigger is a special kind of stored procedure that automatically executes when an event occurs in database. So we have various types of triggers. Let's first see the syntax of the trigger, and then discuss that what are the different types of triggers available in SQL. So we have DML triggers, we have DDL triggers. Let's discuss what are the DML triggers, what are the DDL triggers, and then we'll discuss about the syntax. So in broad category, we can define the triggers into 2 major types. One is the DDL triggers. So DDL stands for the data definition language, which we discussed in the module first, where we created few database objects. So those triggers, as the name suggests, data definition language, they fire in response to the DDL commands that starts with create or alter or the drop of the database objects. Like if I'll create a table, if I'll create a view, if I'll try to drop a table, I'll try to drop a view, or if you want to alter any table, then the DDL triggers will be automatically fired or triggered. The other type of triggers are DML triggers. So they fire in response to the data manipulation language commands that start with, like, if you want to insert some data in the table, if you want to update some records, or if you wish to delete some data from the existing database objects. So based on the commands, these triggers get fired. If we are executing the DDL commands, then DDL triggers will execute, and if you are executing the DML commands, then DML trigger will get fired. We can further divide the DML triggers into two types: after triggers and instead of triggers. Let's discuss what are these after triggers and instead of triggers. After triggers and instead of triggers, let's see an example of DDL triggers and see how they get executed. So let's open Studio and open a new query and increase the font for better visibility. Open our example sheet. So let's first create a DDL trigger. So I'm creating a trigger called safety on database for create table, alter table, or drop table. So if I'll try to create a table in this database, this create table, alter table, or drop table, so it will print a message. To print a message in SQL, we basically use print keyword. And if it is a string, we'll enclose it as in single quotes, whatever the message we want to print. And the rollback, as we discussed, that is the DCL command. So it will roll back the changes, it won't be saved. So let's execute these statements to create this trigger. So the trigger has been created successfully. So that's all about triggers. And these are some of the benefits. It provides alternate methods for implementing referential integrity constraint. So if you want to achieve referential integrity constraint, we have to call instead of triggers. It restricts or controls updates on the database objects and can be used to publish information about the database events like startup and shutdown. So we can call the triggers based on this and we can publish the informations because we don't have to explicitly call. There is no manual intervention. These are auto trigger events. So these are some of the benefits of the triggers. Hope you enjoyed this course and happy SQL learning.
All right. So thank you for the great session, Anil. I hope all of you found it informative. If you have any further queries related to the session, please comment in the comment section below. Until then, that's all from our side today. Thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!